And I will stop the video, save a little bandwidth. I'll go ahead and do your alls as well. Oops. There we go. And again, that's just to give us a little more throughput on the speed. You can feel free to turn your video back on if you'd like to do it, but this way you don't have to sit there and be pretty all the time. All right. So as a lot of you guys already know from what you've told me in your discussion, you know, SCI uses field to finish processing, and you've embraced the idea that that's going to really save you some time and increase your productivity. And that's certainly true. And that's one of my appreciations of the software as one of its top features, is to be able to do that, particularly with larger projects that are just too much data to have to go through to prepare it for once you bring it into the office. So, and even if it's nothing more than putting your points that you survey on the right layers with the right symbols, that's certainly a big help. But the other thing is, and the bigger help to my mind, is that it will generate line work between the points of those same symbols so that it can control the creation of that base map once you're back in the office. Now, it will also do that on the data collector itself, and you can see those drawn components right on the graphic screen of your data collector before you ever leave the field. I'm not sure if you guys do that or not, or if you just use that text screen interface. But if you're using the same code list out on CertCE, it can actually drive field to finish just like you're doing here in the office. There's a couple of little differences, but it's certainly great to be able to let you know at a glance whether you've missed something that you need to go back and gather. So let's take a look at how that system works, and we'll keep that in mind with what we've experienced when we were building our surfaces. The fact that we're going to be looking for point information, and our line work, our 3D lines that also have elevation, will serve as break lines as part of our data set. So, and that's really the foundation of it all. There's a lot of things that are much deeper that you can do with field to finish once you're familiar with that process. Now, I will show you too, there are some things, let's see. All right, here, as part of the first set of data files that I sent to you, you've got within there this thing called F2F Quick Start Guide. Okay, and it has in it two PDF files, one called Easy Start, the other one called Advanced. Okay, so if you use this, now we're not going to go through these today as part of class, but this, and these are both put together by my friend Doug Auberg, who works for Carlson. He also is a practicing surveyor, and he's out of, I think, Arkansas or maybe Alabama, I forget where, somewhere southish. And so this is a nice little, review and a step-by-step, but it has things in it here. He's got these files that are included: CSW, that's Carlson software, example, CFG, which is a configuration file, DWT is your drawing template. Then you've got this tree set up for doing tree surveys. And then you've got these FLD, which are your field code lists. And the one that says CSW ATT will label your points with attributes, the point attributes that you're used to seeing, point description, elevation. Or here's one called CSW TXT, which is set up to label your points with text entities, which are separate from the actual Carlson point that gets generated. So that may be the way you want to practice. You're not going to, give away those point blocks. You're really just using it to drive your labeling. Okay, and then there's a little sample coordinate file. So these are, and you do have to let's see what it talks about it. You will have to, yes, it's over on the the bottom of the second page. It starts talking about loading up load the template file. So you will need to start your drawing with the template so that you get the layer names that the code table is looking for, that sort of thing. Okay. And that's a nice little, and it's more than just really, it's more than elementary. I mean, there's a lot of nuances that are explained throughout this whole business here. But again, it's this easy start. Now, the other one is this advanced, and I think this is where he's going to go into a lot of the tree surveys and pipe surveys. He's looking at code, these companion codes and code swaps and GIS data collection as well. Here is, yeah, using custom attributes that add into, those are your GIS data attributes. Scaling and rotating symbols based on, points that you shoot in the field. I had a guy once from somewhere out in Eastern Virginia came to a class on Surge CE. It wasn't just this class, but it was Surge CE, and his need was he had some symbols that were like parking lot arrows, right turn, left turn, or straight ahead arrow kind of stuff. But he wanted to be able to say shoot the back corner of the turn arrow and the tip of the arrow, and then one point on one of the edges. So whether the thing curved this way or curved this way, then it would figure out how to place it, scale it, and rotate it based on just those. But now he has to shoot, 3 shots for that. But to him, it fit his workflow. So there's all kinds of extra things in here, hatching areas, multiple coding. That's addressing the other one as well. We'll talk about that because points can and should have multiple points when it makes sense. And then it gets into, and it's all the way on page 13, where you're actually going to start the same type of thing. You're going to use some of the same files, like the CSW EX attribute and TXT, and then this tree setup. So it's just a separate sort of run through, but a little bit more advanced than the other file. Again, not something that we have a lot of time to run through as part of this class, but they're there for you to look at, learn, and practice with. And it's a really nicely collected set of documents that, because it works you through a typical workflow. Okay, so those are good. And it's got a nice coordinate file, the nice little data set that will you'll see when you run those things. Okay, so we're going to actually start us up a new file and set our coordinate file. And again, I don't care which is which, or I don't care the name of it. We'll just make a new one. And then we're going to import some points and get started. So I'm going to go to new. And I'll give it a name. I'm going to go to set make sure I'm in my data sets folder. And let's call this one F2, I'm going to call it F2F. F2F example will be fine. I'll keep it there at my 30 feet. Scale, I'm going to set my symbol sizes to 1/10, my text to 800th. And I don't need to worry about this. It's just local coordinates, but I'll just leave it set to that. And we'll go next. And now I could do this as part of this wizard. I could go ahead and do this import, but I'll just show you where that's going to be taken from that same command from the other menus. And so I'll just say next again, and it will come back to a command prompt and we're ready to go. So at this point, as long as I've got my coordinate file and my drawing file, of course, my coordinate file is empty, but I'm going to go to points. I'm going to import text or ASCII file. Okay, now you guys wouldn't typically do this from your field operations because you can actually read a CRD file directly from your data collector, or most likely or more properly, you're going to actually bring in the raw file, do your adjustments, and then take those resulting coordinates. But either way. So what we're going to do is up here in the top window, we need to select any files we want to import. If you choose down at the bottom, if you have more than one file up here, when you select these files, down at the bottom is how you want it to store those coordinates. Either put them all, one after the other into this current file, or ask you for a new file for each one of these files if you want to keep those, sort of one by one. All right. And, or you could create, have it automatically, instead of prompting, it can automatically create the CRD file based on the name of the text file that's, or the ASCII file. All right, so for now, let's choose select files. We'll look at our data sets and we're going to find this text file called plat.txt. And you can see in my preview, I've got point 1, there's a northing easting elevation, and it has a description called FLCM /4 parentheses 4-inch space DIAM close parentheses. You can make out the nature or the format, the structure of that data file. Okay, and it happens to be point number northing easting elevation description separated by commas. All right, so that's what I need to know and use. So again, here's my data preview window. I need to now tell it how to bring that data into this coordinate file. And some of the common ones are point number. You see what the letters mean over there to the left under available identifiers. So we've got point number YXZ, which would imply northing easting elevation and description. So in that order, either space delimited, comma delimited, or it could be, point number XYZ, which of course would put your easting before your northing. So anyway, you can see those and do that accordingly to whatever the data file is you're bringing in. One of the options that you don't see in this list of common formats are these, or two options actually, is skip and note. So if you've got a data file that has, maybe a column in, or one of the items in the data record might be, the date, the date that it was recorded at, just an example, I don't know. But you can build your own format identifier like this, and you can use this up here, skip, if it's something that's not going to fit your Carlson point format, which needs to be point number, northing, easting, elevation, and description. Okay, so we're telling it that this data is laid out for us in point number, northing, easting, elevation, description. Sometimes you'll get data files that don't have point numbers, in which case you would simply leave that off your list, and Carlson will create the point numbers, but this way it's going to read them. All right, so then finally, you can add a value to the names, meaning the point numbers. And if that's a number, it will add those numbers to that. So if I'm bringing this in, and maybe my policy is that, okay, anything I shoot in the field, I'm going to have in my 1000 series of points. So I would put in here, 1000. So it adds, so this point now comes in here as 1003. You can also add a prefix or a suffix, and you could make those alphanumeric. You could say, FLD dash as a prefix, meaning that all these points, came out of the field, whereas your other points you might have created with code commands or what have you. You get the idea there. It's all pretty self-explanatory. You can also filter your descriptions to only bring in those of a certain description. You may skip particular ones. This is, include these. This is an exclude these. This is a number of lines in your data file to skip. Maybe they're just headers that this file doesn't have one. Again, the range of points. And you could also limit that with inclusion and exclusion areas, just like when you're building a surface, the same concept applies. You, of course, have to have those pre-drawn. And then finally, your process options. What do you want to do with those points? You can have it do a draw locate, or you can have it go immediately to field to finish. Right now, we'll just leave them off. You can also create a point group upon this import, in case you've got, 5,000 other points in your file, but you're importing this and you want to, somehow describe that group of points. Point protects. Sometimes your latitude and longitude information, which would normally come out of a note or a description, but you could say, the degrees, minutes, and seconds are going to come in as space separated instead of our more typical DDD.MMSS type of format. So all of those different options, and then we can say, okay. And you should see that it reads in 54 points. So very small file. We'll say, okay. Again, nothing's in my drawing. So I can verify that I had the points hover with my list points, and you can see them there. All right. So the first thing I would do at that point then might simply be to draw locate my point. I'm really trying to figure this out. Sorry. My point defaults. Are continually reset. I'm not going to use annotative points just to make it speed up here. Let me take a quick peek over. Okay. All right, so that should, the next time I do that, I'm hoping it will do that.
What did you just do? I was interrupted.
Yeah, I was getting ready to draw locate points, and like I've been seeing, every time I do a new file, all of these descriptions, elevations, and point numbers, they're all unchecked. So something kept resetting that. I went back to my point defaults, and I noticed they were set that way to not draw descriptions and elevations, not put them on the real Z axis, not use point numbers, not automatically incremented. So I set the point defaults here again, but you don't need to do that every time you do a new drawing or every time you start Carlson is really where this was happening. So I went back to settings to Carlson configure my drawing setup. And I noticed on here, they were not checked. For whatever reason, maybe I was just showing what they do and I had unchecked them. I'm hoping this now would take care of this the next time I start it up. So I've now reset this attribute ID to the one I prefer. I've got my symbol set to be a little tick mark instead of the circle. I've now turned on the things I want to use here, point numbers, automatic numbering, and as well, right? So I say, okay. When I did that, it comes up and asks me, all right, you've changed your drawing setup defaults. Do you want to apply that change to this current drawing and future drawings, or only for future drawings? Okay, and so you choose your choice there. All right. So now we're going to draw locate our points, and I will draw all. And you're going to see them come in with certain descriptions as you look around there. Up here toward the upper middle, you see a UP, then you see shed. You see up here, there's that first one, FLCM / 4-inch DIAM, in parentheses, another EP and MH. You figure that to be manhole, your pavement. IP was an iron pin. In this case, an FL is also a fence line. Here's 2 points, BLD and BLD. We got these 12P, 8P, there's an EPPT, a 24D oak, 18D oak, 18D oak. And there's this 8P, that's an 8-inch pine, and a 12P, a 12-inch pine. So these are all done, and you may notice the oak trees are done differently, designated differently than the pine trees, and that's for a reason, just to illustrate 2 different ways of doing that kind of coding. Okay, so go to then, okay, then I come down here to this bottom, I've got a bunch of PV points, which I would, that stands for pavement, as opposed to EP, meaning the edge of pavement. Okay, so there's a couple of things that we're going to go through that will illustrate a lot of different options in your field to finish. These are not going to necessarily be the codes that you use yourself when you're doing these. You're going to have your own company developed codes, but this is the general nature of what it is we're trying to do. Okay, so right now we have no field to finish having occurred. So we're going to look at the survey menu and we're going to say draw field to finish. Now you may or may not see this dialog box come up. If you do, go ahead and choose split multiple codes for right now, because of the code we're going to be finishing up. That's when there's a space between codes, we're going to assume that that means that point is double coded. It will behave based on one code and also based on the next code. So we're going to split those codes and we'll say, okay. Now, and you'll see where we'll turn that behavior on and off so we don't get that warning the next time. So the first thing we need to do, and these are a couple of set and forget type things, we need to set up the files we are going to use. So if I look down here at the bottom, I see a code table and a coordinate file. Well, right now the coordinate file is my current coordinate file, and that's what I intend to use. But my code table, right now I've got your code table loaded, STI-210416. And that FLD, that means field, or that's short for field code. And by the way, Tom, or any of you folks that are involved with transferring this stuff back and forth in and out of the field with ServCE, you are aware that that FLD can be converted into an FCL, a feature code list, to put on serves on your data collectors, correct? Anybody?
Yes, that is correct. That's how we do it.
Yeah, okay. There believe it or not, there are some companies that never knew that those two files can be interchanged, or one exported to the other format so that you could trade it. And they go to the pretty immense effort of having to build the thing twice. So just want to make sure you're aware of that part. Okay, good. All right, so and this is true of anytime you want to use field to finish processing, even if it's just when you're doing a draw locate points, where it's going to read a code table, or you're going to do some code substitutions on your points. Anytime you see that code table prompt is where you're going to point it to a different or point it to a field code table that you want to use. Right now, some companies will only have one. That will be the default code table that the whole company uses all the time, every time and all the time. Other companies might have a code table that they'll use when they're working on DOT projects, and then they'll have something else that they use when they're working on just private development clients. Or then if they're working on something for the Corps of Engineers, they may have a different code table for each one of those, for each one of those different scenarios. We've even got, I say we, I had a client known as Dewberry. It used to be the old Dewberry and Davis. They're pretty big down the mid-Atlantic region, all along the eastern seaboard, but they do a lot of work for the Virginia DOT, and they have very specific coding requirements for their points, and they have to turn those coordinate files into the DOT, and they have to be in their required format, their required description type library matches. And so they also do work for regional sanitary authorities and Corps of Engineers, all those different types of things, private clients. But the things with DOT is that gets processed over in MicroStation, using En-ROADS or Geopack. I think it's En-ROADS they use. So it doesn't matter. It's all switching anyway. But so and it has its own functionality, just like field to finish, and they need that in that particular format. And in fact, it even gets processed at Dewberry in those other formats. But here was the issue: they wanted their field crews to not have to learn a different set of codes to use for those different clients. They want, if you're going to use an EP, for your edge of pavement, we're going to set up EP. That's what everybody in the field is going to use always, ever, and each time. And then if I'm going to give it to the Virginia DOT, it's going to be called EOP for edge of pavement. Or if it's going to go to the Corps of Engineers, it might be called, EDG ASPH for edge of asphalt, or what have you. But we would take those resulting coordinate files, and the field guys would always call that EP. And then if we knew if it was going to Virginia DOT, we would we programmed up a bunch of converters, converter utilities, so they could just specify the coordinate file, and it would read those descriptions, and it would change them, and basically do a find and replace if you were editing the file for delivery to the other client. So even though I would use multiple FLD files here in the office to process based on different people, different requirements, the guys in my field only use the one set of codes. So they didn't have to try to remember, all those different situations, because, that's just asking too much of somebody to try to remember all that in their head when they're trying to, get in a couple thousand points every day. So anyway, that's all possible and all doable. But in this case, we are going to set our code table. We're going to choose our set button. We're going to, now I'm switched from where I was looking. It puts me in my default location for my settings, but I'm going to change this back to my data location. Well, maybe not. I'm going to go back to, yeah, let's go back to my Carlson. I'm going to go all the way up to Carlson projects, and then my settings folder. And let's find, oh, there's all kinds of them down here. I think this is it. Just find Carlson.FLD. That's one we'll start with. Okay, is everybody able to find that in your settings folder?
No.
Okay. When you go to, if you hit the set button and you're looking for that FLD file, okay, when you're out here, make sure the tab at the top is set to existing, and go ahead and choose the browse button. And then I want you to go up to your drive C, or wherever your Carlson is installed. I presume it's on drive C. It might be a network install. But inside of Carlson projects, there is a folder called settings. And you should see within that Carlson.FLD. If that's where your settings are, I'm not sure. I don't know if Tom, if you're still on, maybe you've got settings set up in a separate place.
Are we still in the training data set folder
No,
under existing?
no. Remember, I switched that. That's why I said go to browse and change that from where you were working up to drive C, Carlson projects settings. Or wherever your settings are.
I'm in that settings folder. It says the 0998 Remington, Kentucky, but I don't have what you have below.
You don't roll that down and see these different options.
I don't see those. I have STI, everything. I don't have Caltrans.
Well, it shouldn't be Caltrans. That's California Transportation Department. It should be Carlson FLD.
I don't have anything. I have just STI.
I don't have anything either. I think I have the same as Sally.
Okay. Any of you other folks have that file?
I have it.
And where did you find it from? In your just default settings folder?
Yeah, just C Carlson projects and then the settings folder under that.
Okay, so so
That's where I am.
Yeah, I had to have a coworker email me this about a month and a half ago. I didn't have it. So I mean I could email it to you guys if you need it.
yeah, just email if you've got that one handy, or I can send it to you guys maybe even quicker. Unless it, if your mail system might have a delay on checking the files for viruses or something, but if I do this field to finish. All right, now let's go here and find. Well, for heaven's sake, my mouse keeps. Let me do a drag and drop. My mouse keeps issuing. I was trying to do an attach, but my mouse keeps doing a double hit on the thing. All right, here we go. Now, Carlson FLD. There we go. All right.
This might be jumping ahead a little bit, but I do notice I'm already pointed at a GIS table.
I'm sorry, say that again?
I'm noticing on the draw field to finish options
Yes?
that I'm pointed at a GIS table.
Yeah. Yeah.
So just letting everybody know.
Yeah, so that's I'll show you what that does though, is that is a table that I've got it loaded here as well. And that's what defines those GIS attributes that you pick up with your points. So you're able to get more than just a description with your points. Say if you get a utility pole, you might prompt for the pole number or the utility type, whether it's electric or telephone or that kind of stuff. Or if you're getting manholes, it might ask you for the invert depth or the inspection condition, any and all of those kind of additional data items, like GIS data. So that's fine, and you should be pointed to the ones that you guys use, and it's probably that STI one. And take a look real quick at this. If I look under here, There we go. So this is in your file. These are the defined features that you can collect. Now I'm looking at a manhole. Here's one called MH. It's got any 2D line work, 3D line work, and these are all, and I don't know what it's prompting you for when you're collecting that out in the field. When you shoot the point and give it an image, it's going to pop up an attribute field and ask you to fill that out. And so this shows you, what it's going to generate. So that's what's driving that particular definition. So you can leave yours set to point to that file. And these are, so if you're, let me come back out of this. So right down at the bottom where it says GIS table, if yours is pointing to that file or any other thing along that line, you can just leave it there. We won't use it with this little example. Okay, but that's what it's doing, is it, you guys, whoever has set that up at your company has done that in conjunction with the way you collect the data out in the field. Okay, so.
I got
everybody-
the F2F now and nothing on the GIS table. We're good.
Okay, so you've got the code table set to Carlson FLD?
Yes, I do.
Okay, good to go. Now, up here at the top, will tell you, what range of points you want to draw. So if you've got several hundred, it might take a little while to to process, and you might, tweak a code and go back and only want to do a few points. So that's what allows you to do that. You can do it by groups, pick them from a list, just choose all. And then what entities to draw: points, lines, symbols, and 3D faces. Any or all of those. And the points, when it says to draw the points, that means it will draw that point attribute, point number, elevation, and description. Lines means that it would draw whatever the codes say to draw in terms of line work. It would draw those, yes or no. Same thing with the points, yes or no. And then symbols would be, if you say did not check points, but you did check symbols, it would put the symbol there where the point goes, but would not put a Carlson point in your drawing file. And then of course, 3D faces as to whether you have any of those defined in your codes. Now you can limit that drawing within, you can limit that to a boundary polyline, or within a radius distance of a certain point, or within a picked square window, like a lower left, upper right type thing, or a coordinate range. Typically, we don't do any of that. Layer prefix, you could decide to, let's say you've got layers that say, one's called utility, one's called pavement, one's called control. And you could have your field to finish process defined if you put something in this box. You might put F2F dash as a prefix, so you don't have to change all of your codes to make it those new layers. It would just simply add that prefix onto the layer name that's defined in the code and use that layer to put the point on, or the lines. All right, now I'm going to bypass this additional draw options here for just a moment, but erasing existing field to finish entities, much like drawing contours, whether you erase previous, yes or no, I'm going to have it set here so we don't have to stop and clear stuff out once we make our tweaks and changes. And then we can erase erase any existing field to finish, or erase in range. That means if I draw in range up here, I'm not going to erase everything, just the ones that I redraw, okay? Preview only, really kind of worthless. What it will do is it will draw all of the processing, but and it draws it with just temporary graphics. As soon as you zoom in or out or pan the drawing, they go away. So again, I don't know what, I mean, that's a way to sort of test what things look like, as you know, so you're not creating items until you're satisfied with your edits. But anyway, that's what it's for. Fixing overlaps, that's predominantly with your point labeling, any of those point attributes or text labels that you do. It will actually analyze whether it's conflicting with another label or another piece of line work, and it will move them accordingly based on a set of rules. I will tell you right now that setting up the overlap avoidance routines, whereas it's kind of a neat thing to see happen automatically, it really takes up more time than it takes to just, when you see it, grab your mouse and slide it over. Okay, so, but it's there if you want to do it. Now, you can go, I think this is new. Do you guys see this triangulate and contour?
No, we don't have that.
Okay. All they've done, the reason they've done that is they've made this an option now. So when you're doing field to finish, which is primarily for the purposes of generating a triangulation model anyway, it just lets you jump right into it from while you're in this command. So that's new in this version. Otherwise, once you're done, you just always go back to do triangulate and contour like you normally would. All right. And again, there we talked about setting the tables up here. Now we'll talk about these two here in just a minute. So before we leave this, let's choose this additional draw options button. And this is sort of like setting up your point defaults, whether you're going to use point numbers, yes or no, descriptions, yes or no, attribute labels, yes or no. And again, those are the point number, description, elevation labels. And then over on the right, elevation label settings, whether you want the elevations to show, labeled in inches. Well, I'm going to turn that off so it uses whatever my current text height is. Label zeros if they are zero. If not, you can leave them blank. Now this prefix and suffix by code, what that means is, or I could uncheck it and put in a prefix and suffix for the elevation, like maybe you put feed space AMSL, above means sea level. You know, something like that. Or if you say by code, then you could have certain codes defined that when you label the elevation, it wants to put a prefix or a suffix. Maybe your prefix might say ELEV equals, but then other codes that don't do it. So this is, if you uncheck it here, then every elevation gets that. If you check it here, it depends on what the code says about it. Or you could simply, you know, uncheck it totally and it all goes away. But using plus or minus means if it is a positive elevation or a negative elevation. And by the way, let me ask some of you guys that have done some of this a little bit before. I was looking up last night where South Portland is in terms of trying to figure out which state plain zone you're in. But I see you're right on the coast, right? Or right on the, I guess, the Gulf of Maine or whatever it is. So I'm guessing you're right down at sea level. Do you, when you do your triangulation, do you, do you leave that ignore zero switch on? I guess that might be why you have that filter set on under the selection tab. Come to think about that, but I just wonder what your approach is to that. Well, it doesn't really matter, but all right, so now again, locating points on a real Z axis, that means draw the point at elevation or not. You can always do it, never do it, or do it based on what the code says. So I'm gonna leave that set by code because I could have a code that turns that off, and that point then is labeled always at 0 if I don't tell it to go on the real axis. Same thing with the line work. So 2D in particular will always be on 0 if it doesn't do it, but even if I'm drawing a 2D, I wouldn't typically draw a 2D polyline at a specified elevation, you know, the way you would a contour line. When we're just doing this as 2D line work as part of field to finish, that's typically just a planimetric feature. And so it's almost universally at 0. But again, it gives me the provision of doing this based on the code definition. Now, the PCPT curve type. For those of you a little unfamiliar with field to finish in terms of processing, what that means is when we read a series of points in order and it comes in, it's going to, again, let's take, you know, maybe we've got a bunch of points that say FC for face of curb. And we see an FC, and then we see an MH, and then we see 2 or 3 more FCs in order. You know, so it will go from that one FC, and if the code says to draw lines, then it goes from that FC to the next FC to the next FC, skipping over any other non-FC codes to process separately. But as it's going, once it has the notice to start drawing the line, it's as if you were drafting that item. And then when you get to a curve as part of that, in this case, their face of curb, if we have a curve in that, we need to identify one of those curves or one of those points as the starting point of the curve, or our PC, our point of curve. And then we would optionally, but in good practice, we would almost always also identify the end of that curved portion with a PT, meaning our point of tangent. Of course, that's where we go back out of the curve. Now, the PT part is actually optional, and if we don't use it, Carlson processes anything it sees after the PC. It does it in groups of 3 points, where it starts the arc, the next point is its midpoint, and then the third point becomes its PT point. But it can also have, let's say you're on a very large arc, or even you're on a S-shaped curve. So it has a reverse curve or something like that, or a changing radius. You've got something like a spiral. So when you start that PC code, it's going to take all of those, any other points that you do before you get to PT, it needs to know how to process. And that's what this option right here is doing. It says, do I want to make that curve a Bezier curve, which is sort of a, it's not really a best fit curve. It's a smoothed curve, and it's not necessarily circular. It goes through the points that you shoot out in the field that are supposed to be along that curved feature. Now, a Bezier curve will create that smooth curve after it processes, not going through necessarily the points that you shoot out in the field, but smoothing a curve through all those points. It's not even a best fit. That's always an actual circular arc, but it's just a smoothed polyline. And it goes through the points you shoot as control points, if you're familiar with the way splines work. Okay. So that's there as an option. So it depends on what type of curve data you're coming in. But the other one we would typically do is sequential arcs. Now, the difference between sequential arcs and best fit, both of those will generate circular arcs. Sequential arcs will take every 3 points, or starts with a PC, takes the next 2 points to define a 3-point curve. It sits on that 3rd point and takes the next 2 points and draws another arc between, where it's sitting and the 2 points to make a 3-point arc. And it keeps doing those as a series of sequential arcs until it gets out of the curve defined by the PT, right? And then finally, so that's a way that you can actually do, switchback curves. You can do S-shaped curves. The other option is best fit, however, we'll take all of the points between the PC and the PT, and we'll put a single arc through those points, holding the PC and the PT, and it puts a single arc through the points based on that least squares best fit option, much like we did with the line yesterday. Okay. And then finally, so again, our more common is always going to be that sequential arcs version. So that gives you the flexibility of getting switchback curves or changing radii. Whereas the best fit, if you only, always, and forever only shot curves or arcs as single arcs, then that might give you the better choice. And then there's the option below that to adjust the PC and PT for arcs to maintain them being tangent to the incoming and outgoing tangents from those curves. Now, what that means is you're going along, you're shooting 2 points along the pavement, and then you get to the start of the curve as a PC code, get another point in the middle, then you go to the PT code, and then you get another point on down around the edge of the pavement. All of that's meant to be a tangent coming into a curve going out the tangent. If you have this turned on, then when you shoot those points, it's going to slide the PC or the PT either backward or forward along that tangent direction, however much it needs to be able to hold the arc that gets result from those 3 points to make that tangent. It's sort of like it creates the 3-point arc, figures out its radius, and then it goes back and it takes the incoming tangent and the outgoing tangent and fillets those 2 drawn items with an arc of the radius that it initially computed. And in so doing, it has to move the PC and the PT up or back based on whatever it needs to do to make it tangent. Okay. And you can give it a tolerance. So if it has to move more than a foot, it won't move it. If it does, it will adjust it accordingly. So again, which one's best? It doesn't necessarily mean that either one's best. It's just depending on what you're doing. And as surveyors, if we're doing a lot of, planimetric work where we're going out there to give a design base to an engineering effort, is going to take our data and work further with it, then we might actually consider leaving that off. We might, because, not every curve in every linear feature out there on the ground is actually tangent. So, our job as surveyors is to bring in what is, not what should be. So we might, consider leaving that off in that regard, or you might keep it on because, what defines the PC and the PT, sometimes that's sort of arbitrary and sort of loosely defined, and it's up to you as a surveyor to use your eye, your judgment as to where you think the actual curve begins. And that's sort of fuzzy. You could be off that point a little bit mathematically, because it's not, there's nothing out there on the ground that has a nice little circle painted white that says, hey, here's where this curve begins. So, use your judgment on that, or follow the company policy, whatever you need it to be. Okay. Then the rest of that is whether we want to create point groups. And if we say automatically by code, then again, it's going to read the code definitions. And if it says put a point in a particular group, it will obey that. It will also ignore the code suffix. So if you've got a bunch of points that say EP for edge of pavement, one of the ways that we work field to finish is that we can start an EP on one side of the road, for instance, and then before we finish that feature, we might do an EP over on the other side of the road or on a different road altogether. At that point, though, we would want to call that EP2 and then EP3, EP4. So those are called code suffixes, and it lets us keep that code in play. Even if we haven't finished one feature, we can start another one, but we have to give it that feature. Otherwise, when we start and stop that line, if we put another start code on the second EP and the third EP, every time it reads that start code, it will stop the previous one. So, and in that case, you don't need to put your suffixes there. It will just be an EP until you get to the stop point or the start of the next EP. And because in that instance, your EP is no longer in use, you don't need to suffix the code. All right. We'll talk about that a little bit later as we look inside the codes. But in terms of point groups, you could say, all right, I want to bring in my point groups when I process this coordinate file, and I want to make a bunch of points called, I'll call them edge of pavement points. And they're going to be anything that starts with an EP code. Well, if you do not have this ignore code suffix on, it's going to make one group called EP, and it's going to be all the EP points, all the edge of pavement points. But we'll also make a secondary group called EP1, EP2, EP3. If you have any of those in your coordinate file, it will make them as separate groups, and that might be what you intend. So you could, limit your point selection to those groups. If, however, you do have it checked to ignore, then even if you have suffixes on your codes, it doesn't make a separate group for each one of those. It makes them all into that single group. Okay. And now, by the way, this automatically by code, that means whatever description is in the coordinate file, the raw description, it's going to make a group of that name. If you don't want to do it that way, but you want to just read the code definition, and at the code definition, and that by this code, I'm not talking about the description, I'm talking about the field code definition, what the, all of that data inside that code for a particular code will say either make it into a point group or not. This one doesn't require you to define it in the definition. This actually just creates a code or a group based on that raw description. Okay, so any and all of those that you want to do, you could also have a group name prefix, and you might call that, say, field to finish dash, so that you know that those groups came out of a field to finish processing run. All right, so a lot of options there that help you with your point management. And then finally, creating point notes. You can create any notes based on your drawing descriptions. And it will read the description that's defined in your code definition as to what goes into the drawing description, even though it's not in the CRD file. And it will create a note associated to that point and attach it into the CRD file if you turn that on. And these options are, keep layers frozen. So if you have a code definition that says when you're drawing this, put it on this layer. And if that layer is frozen now, when you run this, it will keep it frozen, but it will still put those things on that layer. If you uncheck it, then it will thaw the layer so that you can see it. That's usually what we typically want. And then another limitation, I don't know if you have this in yours, draw only fixed GPS points. I'm not sure when they added that. I do know that it's new. Say again?
No, we don't.
I don't see.
Yeah. So that's a way to filter out if you don't, only your fixed solutions are going to be drawn in if you want to turn that on as well. I don't know. To me, it doesn't make a lot of sense to do that. You're going to have other places to control your GIS work, or your GIS work or GPS work, sorry. So to me, it's not something I would ever look at to be here, but somebody somewhere said, hey, Carlson, wouldn't it be neat if? So they gave you the option, right? And then you can see the other options. You can output a Casey file, which Casey is a software design package, civil engineering roadway design package that came out of Alachua, Florida, which is really the precursor. It's what became Civil 3D. Autodesk bought the company and turned it into that. Okay. Now this pause on any codes that are undefined, that means as it's processing, it will stop and tell you, hey, I don't know what this code is. And you'll have to answer a question to have it go on or abort. If you say, if it's unchecked, then it may hit that undefined code and it'll just keep going and it just dumps a point in at that point. So that's really what you want to see most of the time. Auto zoom extents means that once they're drawn, it will zoom extents to show you. You might or might not want that on because you may have some other stuff in your drawing that, it will incorporate that in that zoom level. So, for now, we'll leave that there. To only say allow 3D arcs. It's a little bit of a misnomer, but from a programmatic standpoint, because there are no such things as three-dimensional arcs in the world and in any CAD system, because if an arc has, and I say 3D, I mean with differing elevations. Because that becomes not an arc, but a stretched arc, because you have to consider it in the plane within which that structure lies. And if you raise one end of it up, it necessarily becomes a non-level plane. And if you look at that perpendicularly to that plane, then it's now looking like a stretched arc. So it's no longer an arc. All that does, this allow 3D arcs, is best I can figure out is that it will generate 2D artwork on a 2D polyline, but allow you to do it at elevation. It's either that or it will process the 2D arcs, read the point elevations, and convert that to 3D arcs, which are those series of little line segments. But it does that anyway, so I'm not sure what that switch is necessarily for. All right, so that's, again, a bunch of this stuff is just, you know, fire and forget, but I want you to see what's behind the scenes and what is taking place here, and that sometimes you need to tweak these settings to get different performance out of this, out of the process. Okay, so let's just say okay, and we are at a good little spot to take our break before we get into these codes. And then what we'll do is actually, I'm just going to leave it sitting right here, and you can, if you wish, hit okay. Well, in fact, go ahead and hit okay. And you're going to see, in my particular case, it said it attached one. All right, I see a manhole symbol and the written out description of manhole. I don't see any line work. It said it attached a line work reactor, but I think that's just part of that standard echo. So in any case, in my case, I didn't get anything drawn. You may have a few lines, a couple things that are different, but we'll look at why we did or did not get that when we come back after a break. Okay, so let's take our 10 minutes. Let's come back at a quarter after, and we'll go from there to wrap that part of it up. All right, any questions on anything at this point? Everything good? All righty, well, I will see everybody back at a quarter after. Turn. Okay, so what we were doing, and did anybody get any line work showing up in yours at all?
I got one.
Okay, some people did, some people didn't. All right, so there, I'll show you what's going on with that. There's a file I sent you. I draw field to finish, let's say split all codes, and I'm going to hit this edit codes button. Wait a second. I'm going to set this back to that Carlson FLD and say open, edit my codes. And if I look at that, I've only got 1, 2, 3, 4, 5, 6, 7 codes defined, one of which is manhole, that MH code. And in my case, that is all that drew. I see these manholes, so I got the symbol, and I see that that's on a layer called MH. And there's another manhole up here, and then one up here. Nothing else processed because those codes were undefined. Now, there's something to do some illustration with here. I'll just show you, and then I'm going to send everybody another code table that has more of these defined here in just a minute. So right now, since that's all that's done, let's go back to survey, draw field to finish if you have left that, and bring this back up, and we're still pointed to this Carlson FLD file as our code table. And if I choose edit codes, again, I see just a few of those defined. I've got different categories that I can create. Now, you could, in this case, when we do this and we say, oh, wait, heck, I don't have any of these things. I've got codes in my coordinate file that I don't have in my definition list. So there's a couple things you can do with that. And I've got some buttons down here at the bottom. The column on the left is for the code table. Those on the right are for code definitions. And then in the middle, and then on the right are for these particular feature settings for trees, pipes, and utilities. And then you can edit points, which actually goes into your coordinate file and let you edit the actual coordinate file itself. There's a help system, which, by the way, when you do that, it's a really extensive help system. It's got some really good examples to explain how that works. I'll leave that again to your future exploration, and then you can exit. Now, what we can do with this, while we're here under our code table, this report codes and points, that is the same as this button right here. Okay, so if I just edit codes, and if I report those codes and points, I want to report my code definitions. I'll match all codes, and you could say only report the codes out of that definition list that are in the current CRD file. So if I turn that on and choose OK, I see that's the only code I've got is MH. If that is not checked, you'll see all the codes defined. So what you could do in a situation like this, or you could also, by the way, report codes instead of the code points, you can do by the coordinate file, data points, and now this becomes active. You can sort them by code, and I'll say okay. And so there now I've got code 12P, not defined. The only one that's defined, you see, is this MH, and it shows you which points use those codes. Okay, so that's how that reporting works. But what you can do next is this code table by points. I mean, you're going to create or add to this table codes that are not defined in it based on codes that are in the coordinate file. So if I choose that, I'm not going to, well, yeah, I'll remove any appended digits. That's that code suffixing I was talking about. So it doesn't create a separate code for that. It only creates the base code. And do I want to append the current table or create a new one? Again, you give it a default symbol. That was -15. And I'll say append. And so now I've got more than those 6. I've got all of the codes in this table based on the things that were already defined and based on the other codes that are in my coordinate file. And over here on the category side, I might say add, I might call this one control, and maybe add another one that says utility, maybe another one that says structures, and then maybe another one for pavement, you know, this kind of stuff. You make your own categories, and you look at the ones that are unassigned, and you would say maybe select this manhole. Oh, let's see. I've got, let's see, a manhole, it's a concrete monument. There's a utility pole. ST and STM are probably storm and storm manhole. Not sure. Let's see what else we might have. There's a light pole. And then you could move category. So you select those points and say move to which category. And we put those, say, in utility. So now if I look at utility, well, I guess I just did it from the one. Unassigned, move to utility. All right, so I could, you know, take these and move them individually from here, or I could go to edit that code. And up here where it says category, I can assign it that way as well. All right, so in that case, and we've got, say, our shed. And we'll put that in structures. And then there's a BLD building, move that to structures. Okay, so now we're building these codes separated into different categories to help keep track of a lot of different code lists, okay? And again, you can do that from down here, or you can do that from actually editing the code itself in this pull down up here at the top. And so all that does is put it over here into these categories. Now, that will help you take an unknown coordinate file and start to build a table and start doing it from the ground up. All right, you guys already have a table that you've done at your company, and we also have one here that I'm going to send you here in just a second. So if I go back to, I'm just going to exit this, and yeah, we'll save that, but I'm going to change that Carlson FLD to Carlson NCS, National CAD Standards. Open that one and edit my codes. And now you can see I've got all kinds of codes that are previously defined. Now yours may already be like that. And I've got all codes, or I've got them by category. Now what's the difference? If I say that and say exit and then say okay, it's going to redraw, and it redrew everything there based on those codes with symbols, with different labels, connecting up line work. Still use manholes, although it's a different symbol. Okay, so that code table, let me send that to everyone here now.
Do you know of a lot of people that use the National CAD standard line coding tables?
No, not really. And when Carlson gives you something that says NCS on it, take it with a grain of salt or a great big pound of salt. It's not necessarily set to those. So yeah, we'll just call this update here. And now let me find this one. Yep. There we go. So that's the one I want. All right, so when you get that, if you'll put that one in your settings folder or your data file folder, doesn't matter which. And then go back to survey, draw field to finish, enter that prompt if you get it. And then down here at the bottom, you want to set and point it to that new FLD. Now, another thing to point out with this as well. Notice everything drawn in here is all white because it was all set to by layer. And the layers that you see here, these are the ones that were predefined. And then you see these V dash, that's all the survey layers. And that came out of that code definition. So when it designates a layer to use, if it doesn't exist, it creates it for you. If, however, you have those predefined, different line styles and different colors, then it will place them on those existing layers. And if I go to file, new, and if I choose Carlson, well, it's National CAD Standard Civil. That's not really the one I want. Let's see if I can find. Still I'm looking for. Yeah, here. So this would be my Carlson National CAD Standard Survey. And then it should have I'll set my coordinate file. Back to so now I've got these predefined layers. And if I draw a field to finish, I'm not going to change a thing, just hit OK. And you'll see it all come in. And let's see, it still didn't define those layers. You note site vegetation. Well, in any case, you could site veggie, we might make green. Pavement will make light gray. Let's see, B node. And that's just the node points. It's,
Hey, Ken, I got a question about draw locate points and field to finish. It definitely seems like they're doing similar things. Give me advice on when to use each one. I've just been toggling them back and forth and, looking at the changes, and I'm wondering what the best time for each tool is.
All right, say that again. When you're using field to finish,
Yeah, field to finish. And then when I go to points, draw locate points, and then, draw all. And it seems like they're doing pretty similar things. I just wasn't sure if, there's
okay,
an ideal time to use. Obviously, field to finish draws lines, and
Yeah.
draw locate points doesn't. But
right. And that's when you want to use field to finish, is when you want to generate the line work. And in particular, you're looking for those 3D lines to work as break lines. And if what happens, let's say if I go ahead and just erase all of this and just simply say draw locate points. Now, you could have it set like mine is, it's just points, or, and this is what you're probably experiencing, is on your point defaults, you have set down here to use field to finish for your point styles. And let me check that.
yeah, I do have that.
Okay, so that's done, and we'll say okay. And then if you do a draw locate points, we draw all. Well, it draws them. Oh, I pointed to the wrong table. It's field to finish. Set my table back to Carlson NCS. Now we draw locate points. All right, so that does things like it expanded whatever the code said to use there, the symbols, that sort of stuff. So when to use which is dependent on nothing more than, whatever you want to have happen in your processing. So if you're just looking at points and seeing what they do and you're bringing them in, if you have on point defaults, if you have this unchecked, then it's just going to come in based on whatever these default settings are here, or when you draw locate points, you can override that here. You can set a symbol, you can set a layer, okay? If, however, in your point defaults, you are pointing to field to finish, then that's going to be based on this code table that you choose to bring those in, okay? And all you get in are the points. It won't process the line work. So it will put this, say, on layer V node site vegetation. It puts shed on V node building shed. Let's see, this one is just on PNTS because that VLD code probably doesn't exist in that code table yet. Okay, so I'll go ahead and clear all that mess out of there again. And then if you want, and in the ideal world, this is really the only thing that you would worry about doing to bring your stuff in from a new coordinate file. Go ahead and process it and let it run through all the codes, and it draws a good portion of your map for you so that it's ready to go, including these lines and such. Now, once this processes and does the generates this line work and such, there's nothing in the world that prevents you from modifying this stuff. You can change this, move this over. It's just drawn line work, but field to finish is what drives the creation of that line work. So once it's processed and done, you may need to tweak some of this stuff. Like down here, for instance, I can tell you right now, if I go to build this surface I'm going to get an error right here where this line crosses this line. And it's going to give me a crossing break line error unless they are at the same elevation. Probably won't be, but we'll take a look at how we can resolve that information. Okay, so you could simply just break this off, trim it off at the edge, cut it back just a little bit so it doesn't cross, but you'd still get that little bump up in the surface unless you resolve those things. All right, so once we've done that, we're going to take a little dive into the code edits and work on this stuff so you can see what they do and what your definitions cause in your work here. So if, let's see, what's the first thing I want to do? Take a look at that. Break line, no plot. Okay, that's fine. I'm going to set my break lines. Break lines, no plot. I'm going to make that tab. And I'll even disable plotting. So this is nice in that it will create my 3D line work. And even though I may even leave it showing, with my layer still thawed, when I plot, it won't plot that 3D line because I may have it also set to create 2D line work. Okay, in which case you're going to wind up doing things like, I can see right here because it's on that set of layers. And if I look at mouse here, if I look at that, I see that it is a 3D polyline. But if I'm drawing a shed, I'm going to want that to be a 2D polyline so I can, I can label it and keep it down at 0 and I'll freeze off these 3Ds. So let's take a look at what we're doing with those. So let's go, and there's two ways of doing this. We're going to do it through this heavy code edit business, but I want to show you these other two commands right here real quick. This field to finish inspector, for instance, if you run that, you're going to get this little split screen deal, and you're going to see your codes. If you select any given item, it's going to tell you which points. That's what this instance over here does. And if you choose out of this instant list, it shows you which particular point is going on. Now, within that, when you choose that, now you can say zoom, isolate, zoom, isolate, and restore view on exit. So if I wanted to see, let's see, my PV points, my pavement points. So see what it's doing? It's showing me where those all are. Here's my instances, and it's then splits out individual points. Let's say this point number 42. If I scroll down here and find point 42, let me turn off isolate and zoom. If I look at point 42, I see it has a code of PV, but I can also give that right here an additional code called MH, for instance. And if I apply that, it wants me to select what I want to apply. Now I could, if I check this, it will update my coordinate file directly. If I down say split all codes, and now you see 42 has two different instances based on it having a code of, back here, find 40, well, 42 is no longer there. I've got now. Yeah, I took it out of my list. But in any case, when you can change these things right here, and if you actually, let's go to point number 42. All right, it was included in MH. If I apply that, okay, it's already hadn't changed anything. All right, so I can exit that, and now that point number 42 has two, and it's actually drawn 2 points. There's point 42. MH centered right here because of the attribute layout ID. Here's a duplicate of the same point. You see, it's still that point. It's a matter of the fact that it drew 2 points. I probably should go back to my point defaults and say avoid duplicates. I don't think it's on there. All right, but anyway, I could simply just delete one of those there, but that now has a code of PV, so it participates in this work. It also draws this symbol, and it puts that symbol on this manhole layer, but it's also part of this brake line layer. And then if I double click that point, and I'm now editing the point from the CRD file, you see what happened is I updated that code right there with that little inspector. Okay. So that's one way that you can take a look at that, and it only deals with your field to finish stuff. Let's find the shed points, for instance. Now I turned zoom off, so I can roll the wheel mouse and do all that around to get those showing for me. So I've got those codes. I can go to that instance and go to any one or the other or all three and change, modify these descriptions, that sort of thing. Okay. So that might be a handy way to step through your code edits, or under survey, draw field to finish. I'll answer that again. I'll come back here, and now you're editing these codes, but here's where you can also just simply edit points. And this is your editing. If I look at that point 42, for instance, now, see, that's where it became PV and MH. And I could then save and exit, and then maybe I'm just going to, let's redraw the PV points. It should be more than just.
Yeah, hey Ken, I got a question for you.
Okay.
So when we're collecting data in the field and we're multi-coding,
Mhm.
we have to code in such a way that the symbol would be first. Like you've got pavement first, then you have manhole.
Yeah. So
Like if we code that way in the field, in the collector, the manhole symbol won't show up.
Okay. Yeah,
Unless we'll do symbols first and then line work afterwards, and then everything will come in.
okay, and that's fine, and that's controllable right here. Go to draw field to finish, and this is where we're going to start to get into these edit codes. So I'm going to edit the codes, but instead of actually working on that code itself, come down here to your code table settings. Now, this is something, and this doesn't store with the code table, but it stores with the machine, with your computer setup. So again, loads, save as and loads will be helpful here. So here's where you set that behavior, and there's a lot of stuff in here that controls things, and we'll see it back and forth. The first thing that we'll talk about here is which method, Carlson, land XML, Eagle Point, SDMS, or KC. Well, we're going to use Carlson coding. You guys are using Search the E, so that's just a different method of coding. This over to the right now, where it says split multiple codes, you notice when it came in, it prompted me because it found multiple codes. If you always are going to split your codes, you can just say all and you won't be prompted. Or you can say none, in which case anything after that space, it's looking for a code designated as PV space MH, and it treats it as a single code. Well, this won't find that because I want to split those as dual coded points, multiple coded points. Okay. And now over here under use multiple codes, I don't know what yours is set to be, but you can do line work and points or line work and symbols, in which case the symbol that the line draws and that the code draws and the line work that connects those codes, if defined, would be what draws, but it doesn't it doesn't necessarily prompt the other definitions under points. So it's more typical that we do line work and points. Otherwise, if you do line work only, then it will disregard the point definition. And when and by the way, this points, it will always process the first point. So if you did manhole first, even if you said line work only, it would do the manhole first, and then it would process the line work on PV. And let's say PV, you wanted to show a little X for a tick mark, it would disregard that second point and only take the line work. But if you wanted both points, then you would choose line work and points. So you could have multiple symbols even on a single point. But now, what determines the code, or I mean the order that you want to do is going to be this down here. And by the way, this up here is where you're going to import your field, your data collector, code table, your FCL codes. You can import them into this, or you can export this table out to be an FCL list for your data collector. All right, so here's how you're going to control some of that, the order. So if I'm going to draw field codes that don't have a suffix, so if I'm drawing edge of pavement, for instance, and I have an edge of pavement and it draws lines, and maybe it also, puts the point down either with or without a symbol. If I have that checked on, then when I'm out there and I want to be drawing lines, I have to put a suffix on that code. I make it EP1, then EP2 for a different edge of pavement, EP3 for another one. But if I just say EP, it's just going to put a spot point, give it that code, but it won't draw the line work. It ignores the line coding. Now, we don't typically do that, but you may have, if your workflow is set up to that, that gives you that option. You can also stop line work at a gap in point numbers. So if you come down to where your EPs, you give it a start code, you go along, get a bunch of EPs, but then if you go over and get something else and maybe pick up another set of EP, maybe on another side or somewhere else later on, that becomes a gap in your point number, excuse me, and it automatically puts a stop code on that first one. So Again, not typical. I think the better approach is to always purposely put a stop code in when you're done drawing that line. But now here is, let me see under special codes here a second. Not yet. All right, so do you have I'm not doing that. Skip. Do you have any of those things checked on yours? And yours may not be exactly the same as these. These are somewhat newer.
No, we don't have any of those checked. Mine was checked though, the multi-code line work only.
It was set to line work only. Okay.
Yeah,
All right. So that would be why you put your symbols in first. And even though it says line work only, it doesn't ignore the first symbol, only everything thereafter.
yep,
Okay.
okay.
So that's what drives that behavior, but you could have it set to line work and points, in which case the following codes get processed just like they were separate points done again. Line work and symbols will not put the second point in. It only puts in the symbol defined for the second point. Okay. Also, we'll draw lines that those secondary codes require too. So, it gets treated the same. So if I'm out here doing these, where this driveway PV crosses my EP points along the edge of pavement, if I have a single point down there, call it PV and EP, as long as they're in the right sequence, it's going to come up there and continue that line work, and it would continue the PV line work as well. So that's a case where if I'm shooting these, and if I shoot this common point and I want my EP to connect between, and even though this is set to draw a continuing figure, if I set it to be, well, it can always read the line work. If I say, yeah, it's still going to draw both lines. I was going to see if I could interrupt that, but not. So that would be where you would do that. Now, what do you have down here as your options in this corner?
We have the same as what you have there.
Okay. So if you do use preceding special codes, I'm not sure exactly what. If I find where that's going to be. Go without, okay. Use multiple codes, how to draw the additional codes. Draws a point based on the primary code and then suppresses that if you want symbols for all codes. Yeah, but it doesn't put, see, when I do that before, it put 2 physical points in my drawing, even though it was just 1 point. That's why I had that doubled up point. So in that case, you might set that to line work and symbols. But now, here's what I was looking for. They expect the special codes before the main code. So if that's a special code for EP, the main code, it looks for that. The default sequence is for the special code to come after. So EP began. All right, so when you start your line draws, do you put the code in and then the start code, or do you put start code first and then the symbol?
Code and then starter. It's
Okay.
Yeah, ST.
So that's what this does is if you do it the other way around, if you always put the start control in, that's a special code for starting. Or like a PCPT, any of those special codes. If your workflow is that you put that in before the actual code, you would check this. Otherwise, it's looking for that special code after the code definition, and that's more typical. Okay. So now, if we look at this for a minute, I'm going to edit my points and look at these points and just come down here and find a couple. I see this one up here is a double code, fence line and concrete monument. That's just a single code, but that slash is a special code. Iron pin and fence line, that's a double code. I'm looking, now here's my PCs, and notice there's no PT, like really this should say PT. But if you don't use PT to stop the curve, the next time it finds, it will use 3 points. It will use the next 2 points to define the arc. And if I had more PVs in there, it would not, it would start drawing straight lines in between. And then every time it hits a PC, it looks for a PT. If it doesn't find one, it only takes 3 points. If it does find a PT, it takes all the points in between and then stops the arc. And then a PC restarts a new arc. Here's a case where PC, and there's a PC way down here. So in this case, only those 3 points will define that. Now, when I get to this one, 46, that's EP, there's 1, 2, and then it skips over hub and picks this one up as the third one. And there's no PT, so then at this one, between here and here is a straight line. So my preference, what I would consider my best practice would be I would always put PTs where I specifically want my arcs to end, because that way there's no confusion. All right, now, if I look at my very first EP point, which is 45, and that's this one down here. So 45, 46 starts the curve, 47, 49, and then 51. Now, in this case, you notice there is not even a start code. And there's no stop code. Now, to me, the best practice, now what do you guys use for your start codes? ST or BEG or what?
ST.
All right, so to match yours, I'm going to come here and say EPST, and I'll go to the end of it. And how do you end it? END?
We usually don't put ends in it. We just, remember and start over again.
Yeah, okay, and that's fine. Those are optional codes, but to my way of thinking, to make sure we don't have any ambiguity on these, especially if you're using if you're using suffixed codes to get other features while that other one's still going, because you could go, EP, 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 and it's supposed to end there, and then you're going to go over here and start a new one. If you don't end that one, or if you were to forget to put the start code over here, it's going to draw the line between the end of that feature to the start of the next feature. So that'd be a stray line that you didn't need. But if you have a start code over here to this new feature, that knows to go back to the last one, turn it off and restart. That's the way you do your work. And that's okay, as long as that's not causing a problem. I just
we'll separate them too. Like if you're running two sides of a road or something like that, it'll be EP1, EP2, EP3.
Right. So you're able and aware of the fact that you can start multiple features. As long as you put the suffix on there, that's exactly what that's intended to do. Okay. So, and again, like I said, you don't need to put that in code there. It's optional, just like the PT is optional. My preference, however, is to always do that. And I would come in here and put PTs. Now I would, normally not have to do this in the office. This would be already coming to me from 1, 2, 3 from the field, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. PC 1, 2, 3. Oh, that one already had. Let's see, was that? Oh, 49 to 50. I'll save that and let me go back out here and double check where is 50. Yeah, so 50 is the PT. It was already coded. Okay. So as a PT. So there's the first one, and then these 2 points. So that's an arc, and then that's an arc as sequentials. Oh, sorry, problem with point and shoot. All right, so I'm back to my code table. I'm going to look at my special codes, my code table settings, and then I'm going to look at my special codes, and we'll talk about what some of these mean. So there's a whole slew of special codes that are available to you that actually help you create your line work mostly. So when you depending on how you collect your data, you're going to put in the code, and then you're going to put in a special code after that code. And it's whatever these are defined to be. And again, these won't necessarily match what you're using or across the board. So you have to make sure that this gets matched with here when you do a save as and load, so that these will match and everybody across the company. So you could say put an NE after something. Let's suppose you're shooting, fire hydrant points. Okay, so you could shoot a fire hydrant, and if you usually shoot the ground and give it an offset so that the point actually goes to the center of the fire hydrant, but you're shooting the ground so that you get the elevation, then if you want that fire hydrant to be considered when you go to triangulate and contour, your code, your FH code would not, it would create the point and it would be a candidate for being in the surface. But let's say the next, one of the times you pick up a fire hydrant, you don't shoot the base of it, but you actually shoot the top of the nut on the top of the hydrant. Well, in that case, you would type FH space NE. So it will record the point and it won't record the elevation. It leaves it at 0 so that that doesn't get included if you want it that way. Or you could use this NOS. It says non-surface. That's the same as if you made the point itself non-surface, either by the code definition or you went back later and edited the point in the point editor and told it to be non-surface. But this is a way that if your codes don't turn it off globally, you can, for any given one, you can tag on that non-surface. Okay, so these other codes that we're going to see here, we're going to see this one, which says anything after the slash character, we're going to append to the description that gets written into the drawing. If we use this backslash, then that means anything after the backslash gets prefixed into the description that goes in the drawing. And then double backslash and forward slash means that you're going to prefix the actual field code or append or suffix the actual field code. So if I used MH, let's say I used MH and my MH code is defined to write out the word manhole. If I put MH, then backslash STM, then it would, when it processed the point, it would write out the word manhole, but it would put STM in front of manhole. So I know it's a storm manhole. Or if I put the forward slash, it would say manhole, and then you might have, you know, forward slash parentheses STM or something like that. So it suffixes it. If, however, I put a double backslash and put STM, then it prefixes the actual field code, not just the description, but the code itself. So it makes the code into STMMH. Now there's not a whole lot of profit in that necessarily. It's there that the reason it's there is that it, you know, if you're going to do that and it makes it into a code that says STMMH, then it goes and looks for that code to process it accordingly as STMMH. But if you're going to have to type backslash STMMH, you might as well just type STMMH and let that code control it anyway. But in that case, that's what it's for. You can put a triple slash in this case to override what the code description would write into the drawing and replace it with whatever you type. Okay, so that's how a lot of these kind of things work. We won't go through all of those. Here's some point rotations that you can set to control those. You can link a photograph. You can set a symbol size and distance for these multiple point codes, etc. Now, the ones that we're going to use most often are our start and stop codes. And to match yours probably already say ST. I'll change mine to match that. You don't typically use your end codes, but I'll just leave that as END. Start my curve, PC and PT to stop it. And let's see, look at here. Close is one that we typically use to finish drawing the polyline by closing back on the first point. We don't have to go back and shoot it a second time. We have rectangle codes that will take typically any 3 points that we draw, it will go ahead and draw the fourth point to make it a rectangle. So if we remember that shed that we drew, it only had two sides, it used 3 points. If I were to say rectangle, it will draw those 2 sides and it will go ahead and finish it off as a rectangle. Now that also works as, it will also work with just 2 points. I'll show you how that works in here in just a second. In that case, we have to supply a distance, how far away from that it goes. Now you've got offset codes, and this is for drawing your 3D lines that you're drawing. It doesn't have to be 3D, but it will create a secondary line. We'll offset it from where the point is to a horizontal place. You've also got vertical offsets. So these are good to create curb lines, offset something horizontally, offset it vertically. And then you can offset to the left, which is really, you can do an offset and just give it a negative distance. Both offsets, it's like you're actually coding the center line of a double line feature. Only offset won't put the line work in where you're shooting the point. It only creates the offset itself. You got circles. JPN is one we probably use a lot. That means join to point number. So if I go going out and I've shot a building, and then I go over and I shoot this power pole, and it's got a power line lead that runs over to the building. If my power pole codes say to draw the electric line between my poles, then if I say JPN 37, if that's the corner of my house over here, it will also draw that line up to 37 to just show the connection over to there. So that's joined to point number. And again, it only really controls the line work. It has no effect if your code doesn't draw lines. Now, here's one that we could use a lot of as well. We'll see an example here in a minute on that building code. But what what jog does is when you're in the process of drawing the line and you're at a point and it says, and you give it a jog code, well, your codes that you can use for jog, let me, if I can find it. Here real quick to show you the examples. Codes. Must have passed it. Oh, here it is. This is the same as the regular drawing command of extend by distance. And this lets you draw the extra line at particular stops and turns, etc. And so the only thing you put after that jog code are going to be offsets. And the offset that you're going to be is you're going to jog to the right, or you're going to jog to the left. You can use positive and negative to indicate that, or you could put R in the distance and L in the distance. And then also you have an S, which means to go straight. So you go straight ahead a certain distance. So here's an example. I've got a building where I may have shot, one corner, but I can't get to the other corner. I'm only able to get up, maybe there's a rose bush or something in there. And so I can shoot another point along the face of that building, but then say jog S, 10 feet, because it's 10 feet away to that corner. Which I might be able to put a tape on it, but I may not be able to see it from my setup, or if I'm using GPS, I may not be able to occupy the corner. So I'm going to go straight ahead a certain distance. Then I'm going to go right 5 feet, and then left 12.2 feet, and left again 12.2 feet. And then you could, or put the negatives in for the negatives for the left. And then when you, and these are always done in the XY plane. All right, so as it's drawing that line, it's going to create those jogs. It's going to just extend that line and work its way around to finish drawing that figure. So it's just like drawing a polyline, if you will, but it has these jog codes, and it can just create the line work without having to go and actually occupy those points. So let's see, so the start is a line work. The point what it should be. Now here's something we have is parking. Let me close this off. You probably don't have this parking code as one of your special codes, I'm guessing. Or do you?
No, I don't believe we do.
As well as ramp?
No, we use stairs. Maybe I don't remember a ramp. We
Okay,
use like steps on it.
all right, so ramp and parking, I'll show you.
Or
what
deck.
they- Yeah, I'll show you what those do here just with, let me show you down here. Right in here. So here's an example of, you would say PP parking. So it's a special code that draws parking stalls. So you would say PP, you'd shoot the start of this parking lot. If these are the stripes, so you would come here and say PP, that's for your parking place. Parking, whatever code you type into that box, 8. So that's going to go 8 feet. And then it's going to, you give the next point up here is PP, that sets the direction of the stripe. This parking 8 sets the width of it. And then you would come over here and grab this last point, and it will draw these in as 8 feet away until it gets to that last point. So if this is not exactly 8 feet, it will still put this point where the point goes. So you could say, instead of measuring every one of those stripes, you could hit here and here and close it off here. Now the ramp, this curb ramp stuff is really handy if you're dealing with some standard curb structures. Now, again, as surveyors, again, our job is to bring back from the field what is, not what should be. So this is going to rely on this being a fairly correctly built ramp.
We do a lot of ADA as built. So is this a way that we make those better?
It could be, I mean, it could give you additional, you can save a bit of time, because what you would do is you would type in here, let's say we're running back of curb. So here's a case where it's a back of curb ramp 3, 2, 1, or in this case, bottom of curb. They're talking, I would call that FC for face of curb. So it's the bottom of curb, and then ramp says when I get down here and I shoot this point, it's going to say, it's going to go 3 feet for the width, 2 feet for the depth. So it's 3 feet across here, 2 feet this way, and then 1 for the taper. So we would shoot that point. I think it's right in here. I don't think you shoot the center of it. It might be that you shoot the center. You just go to the center and shoot that point. I can't remember which it is. You have to test it and see. Anyway, you'd be coming along here, and then you come up here and you grab this point and you would measure these in. You would put in the width, the depth, and the side taper distance. So if you're going along and your curb is creating 3D line work, which includes this line, the top of curb, the back of the curb, because you're using offset verticals, for instance, to create all that 3D line work. When you get here, it knows where to start and stop this flat, or it's not flat, but this inclined part of the ramp. It comes back here, the depth, and then 1 is the side taper. That it comes out, it sets half the width to create this point, and it comes back a foot to set that point, and it keeps that point consistent with all the others. But when you shoot this point here, it has the effect of depressing this curb along this line. So it brings it down in elevation down to here, and then creates these lines as 3D line work back here. Okay. So that may be something that would help you if you get some fairly standard type ramps. But if you get something that's built like this, and it's sort of, built at an angle over here, and this one's 1 foot, this is 1.5 feet, well, then you have to shoot all the points to get, again, what is instead of what should be. So just use your judgment on that part, but it could be something you do. But that was something new, I think, in 2021. It might have been 2020. But that's a new code. This parking code, that's new in 2022. That's the first time I'm actually seeing that. So like I said, you might want to consider that if you guys, I think you're planning on upgrading at some point anyway. So that just, explore those options and see what those can do for you as well. Now, I think that's all we need. Let's see, CLO. We're going to use line type width, gap, smoothing. See, these are all codes that control drawing line work. In fact, you see this box around it up here. It says line work special code. So these are going to control as if you're drawing the map while you're out there in the field. Okay. And if you shoot 2-point circles, what are you shooting? The radius or the diameter? The third rectangle point, you would either shoot it on the corner or it could be anywhere on the rectangle that is just to define the offset. And that's a case whereas if you have like up here, if you can see that those two legs of that rectangle. Right now, my third rectangle point, if I go here to here and my third point up here, I'm telling it it's a corner. So when I give a rectangle code, it's going to go from that point to go over here and close off the rectangle. If, however, I say it's an offset, then it's going to take these 2 points. It reads that and it reads the rectangle code and it says, well, instead of going to that point and making a rectangle, just go from these 2 points, go exactly 90 degrees. So you may not be exactly at 90 degrees, but that will go at exactly 90 degrees at that distance and then close that off as a square-sided rectangle. Okay, so typically you will get the corners. That's a good way to get, drain inlets and such like that. You would get the 2 points and either go back and grab the back corner and then give it a rectangle code, or you would get the 2 points and give this one a rectangle code. And you would also type after rectangle the width of the offset, either left or right, negative or positive. All right, so we'll see some of those when we mess around with some of this stuff here. Now, a couple of other things that it will do as well in this code table settings is this max delta height and max length. And that is if you do not use start and stop codes necessarily, but you're doing, I'm not sure of a good example would be, let's say you have a code called, we typically would shoot it separately as toes and tops. If you had a, well, let's say you're going around, you're doing a bunch of EP points along a road at the bottom of the hill. And then up on the hill above you, you got some other EP points up here. And if you don't start or stop those things independently, which you guys do, so you're not going to necessarily have that. But if it's over whatever this distance is vertically, it knows not to connect those. Same thing as if it's further apart than this number horizontally, it knows not to connect them. Now that has a very profound effect on some things. I had I'm doing a class down in Houston, Texas, actually out on a road that when I first started my career, I did all the surveying out there where we were picking up all the driveway entrances and culverts along this road that they were widening. Well, as you know, Texas is really flat and the roads are therefore really straight. This is about a 6-mile long piece of road that they were widening. And so we would get a culvert shot under a driveway. And so we would say, CLV and then CLV to get both sides of the culvert. And then if we were doing CLV start, and then if we didn't put the end code on the next one, and then we went, these houses were like half a mile apart. So we would go CLV And if we forgot to put that start code again, then it would go from the end of the previous culvert and it would draw that line a half mile down the road to the start of this next culvert. Well, you still think you would see that, except for the fact that, you know, a half mile apart, a culvert up near the edge of the road, that is nearly visually, it looks like it's right on top of the edge of pavement lines. So it just created a real mess for these people that were doing it that way, because they had neglected to start each one of those things with a start code. And so if they had a particular distance, you know, 1,500 feet, if it's further apart, then I'm going to say, well, you know, not to connect those. In fact, 5,000 is probably way too big. I may just put that back to 1,000. All right. And you can have a default distinct point layer with a prefix and a suffix for anything the code definition says as a distinct layer to put the points on. So again, just something that may help you in the housekeeping as to what layers these go on. All right. So that's sort of the basics of those. And when we come back, we're going to look at these and figure out how we can actually generate the rest of this drawing, that you would see some of the options as to how this stuff works. Okay. So let's go ahead and save that. And I'm just going to say cancel. I'm not going to redraw it at this point. And, you know, save the drawing. So we're right at our lunchtime. So again, I'm going to give you your full hour. So let's come back at 12:35. Any question? Oh, that's why I need to. I see what happened. Let me go back to this guy and close him. All right, so any questions that anybody may have? Everybody good so far? Have to have example there. All righty, so let's reconvene at 12:35, and I will pause the recording. Just to sort of re-summarize, you know, what we went over with field to finish and such, there is basically when you're generating your drawn graphics that you are going to want to use sorry, get back to this. So you're going to want to generate the break lines and points that will be used to build your terrain model, to build your tin surface. And also then, because they'll do double duty, see, I've got two, well, I've got that layer frozen, but as you generate those codes that say, see, that generated a 3D polyline and a 2D polyline. Now, the reason for that is if you look at this 3D polyline, you remember there's an arc and it has to replace that with individual line segments. Whereas if I look at the polyline, I see that that segment is a true arc. It only has the endpoint and the endpoint and has a radius defined for it. Okay, so you're going to use field to finish to help create all of that line work that you would otherwise have to bring back in the office and set down and play, connect the dots. Okay, it also establishes your symbologies, and you've got other things that you can do with it in your field codes like jog codes, rectangle, close, all those different kind of special codes. And the secret, of course, is to just make sure that you are storing in the field the same description for the point that is defined in the code list. And I think you guys have a good handle on that already with the setups that you use. So just make sure that that stuff stays coordinated and then realize that, you know, once it generates that stuff, there's now your base that you can continue on your way to build your final deliverables products. Okay, so now let's talk about some other tools here in our survey toolbox. Let's make a new file. Let's place it in wherever you choose to put your drawing, and we're going to call this one additional tools, for lack of anything else. And we'll let it name our coordinate file. We'll make it a new file, no import. We'll say next, and off we come. Now, a couple things I will set is I'm going to put my LT scale back to 1. But not this became, but view res to 20,000 already said. Okay, so you can have to do it later. I'll make a new one called P TXT, and I'll set that to my calligraphy light. All right, so I'm ready to start doing some of these other tools. And again, remember that all of that stuff that you generate, whether it's through field to finish, or even if you are at some point drawing lines between points or just creating things out of CAD entities, at the end of it, all of that work, everything in this drawing that you are building is still just plain old CAD entities. And you are certainly free to make them with any tool that you like, whether you're using CAD tools or you've seen hopefully some of these draw tools like your 2D Poly that let you use point numbers, and it's got different options like following another line, all kinds of different little enhancements that Carlson gives you with these Carlson routines. So we've pretty well beat this stuff half to death. And now let's look at this deed section. So we're going to, if you look in the book, there's this previous page, we talk about this on the survey menu, this deed reader. And I'm not going to put you through this exercise for this particular reason, that this is a real tedious thing to try to get all this stuff matched up. And here's what it does, how it works, is you have a bunch of text from a deed, and you can bring that in from a text file, a Word file. You can scan it and do optical character recognition, however you want to bring those files in. And then you set through these settings down here. You pre-build those settings to do things like when it sees something that flags the fact that it might be a bearing, like an N space or an S space, and then you see, you know, so many feet. So it matches all those things up. And once it does, it automatically reads that text and processes it into what that text becomes. And I say that it's a little bit tedious because I've had deeds that I've seen where sometimes they will have, you know, S space, or they'll write out SOUTH within the same description, or sometimes they'll use a degree symbol or they don't, and they use dashes or whatever it happens to be. 209.20, they'll spell out feet or they'll use a foot symbol. So you have to code for all of those particular options. Now, where this will be helpful is if you are doing a whole bunch of deeds that you have to recreate, and they're all out of the same type of description. You know, maybe in a subdivision where somebody has prepared all those descriptions and they're all consistent. So once they're consistent, if you set these codes up, it can have it just read through the text, and you don't have to sit there and draw each individual deed. So it can be helpful for you in that regard. Okay, so, but this exercise will step you through that in the settings, but just realize that the settings are tedious to get matched exactly. And every time you switch to a new description, you're back to setting new settings unless it happens to match the last thing you did. So for sake of time, let's jump ahead and go to the next one, where we're going to enter a deed description, and we're going to put in the deed calls and then see some other tools that we can do with that, because the net result will be this will be the same thing as having done this, and it generates this parcel information and stores it in a deed file. So we're just going to manually do that process on this example. And if you've got your book handy, look on page 72 to find those calls. If not, I'll try to switch this up if you can read it out of here. We're going to start with the POB right here. And so what we'll do now is go to survey, and we're going to say enter a deed description. Now here's some of the setups: a particular layer and curve, or line and curve layer. This is where it draws. If you choose to draw the line work down here, a layer to put the points on. And I'm going to put this on points underscore deed. Set my symbols to a 10th. I'll leave my text at a 10th. I'm going to basically traverse by bearings, and I'll put the whole points down there so that I'm not going to apply any particular rotation. I'm just going to put in the straight deed. I'm going to label the lines and arcs, and these line and curve table settings are by default. You can edit those or change to a different settings file. Some general label defaults, or you can change that. And then the deed name, you could type that in either PBV and page designation, or if you know the owner's name, whatever you want to call that. We'll just leave this at lot 1. We will draw the line work, and we can prompt for descriptions. Create polyline means instead of drawing individual segments, it's going to create it as a continuous polyline. We will uncheck prompt for elevations and prompt for the true point of beginning. My plot point symbols is unchecked right now because I've said I'm going to use complete points, so it will include that automatically. And you could also store this into another raw file that you could edit later, but we're going to store it to a deed file down here, and that will be what we edit. And you can have that create a new one, or you can append an existing one. So as you keep entering a new deed, it keeps adding to that. So your choice for that. It by default will fill out the deed file to match your drawing file name. If you need to hit set and choose another one, you could do that as well. And so we say, okay. And now we've got our settings done. It says pick a point or point number. Well, I'm just going to go out here anywhere in my screen and just pick a point. And it wants to know, reading down here on my command line, it's prompting me for a description. That's going to be my POB. And now I'll zoom out a little ways. So we're not sitting in the, zoomed into it. So now at this point, we're going to start putting in these individual deed calls. So I'm going to go north 25, 30, 45 east, a distance of 165, 45, 30, 45 east, 165.45 feet. Now here's how you enter those calls. It's asking me to, well, it's telling me field to finish code is not found for POB, and that's because I've got that set my point defaults. That's okay. But it wants me to now type in either an E for exit, C for curve, S for select, or bearing. Now that's my angle bracket, so that's going to be my default. And the format to use is Q, the quadrant number, and it's 1, 2, 3, 4 around the clock, northeast, southeast, southwest, northwest. And then degrees, and a period, then minute, minute, second, second. So that bearing is going to be 1 as my quadrant, then 25.3045. All right, so it knows the direction it's going to head to. And now I need to tell it what my distance is, and I can choose varas, meters, rods, chains, or distance again in brackets as my default as feet. And so that distance would be 165.45. All right, so there it's now drawn with my settings that I have, and it wants to know a description. I'm just going to call that one COR for corner, and it creates the point.
I'm coming up with an invalid angle.
What did you put in as your angle?
160. I didn't get the same message you did. I had
Let me have you share your screen real quick.
it was the bearing I put in. It was the bearing I put in wrong.
All right.
I put 125.3045.
You left out the decimal place.
Okay.
Correct. Yeah, that's what. All right. So
Okay.
if you put the
Let me
decimal
go.
between the degrees and the minutes, that's the only place you need to put it. So it's QDD.MMSS. Okay. Did it allow you to keep going, or did you need to escape and
I
start?
had to get out.
Okay.
Okay. Thank you.
All right. So now it keeps prompting me for now the next bearing code, and it uses the same one I had as the last time as a default. So I'm going to change that now to be southeast. So that's a 2 quadrant, and a degrees is 45 minutes, 00 at 200 feet. So that's going to be 2 as my quadrant. What was that? 45. So 245. Now I could put 0.0000. I don't have to do that. It assumed it if I leave it off. So I could just put 245. And the distance is 200 feet. It wants to know the description. I'll leave the same as COR. So it's now done that, and it wants to know the next quadrant. Southwest will be 3. 25.3030 at 156.78. So that's going to be 3 for the quadrant, 25.3030 3030. You don't need the 0, but you can have it there. The distance now is 156.78. The description COR. Now I'm going to zoom out so I can be sure I'm looking where I am. So you can see that 25, 30, 45 and this 25, 30, 30, it's close to parallel, not exactly the same. So now the next point is going to be a curve. And it's going to have a delta of 50, 0802, 200-foot radius, and an arc length of 175. All right, so at this point, we need to look at our options on the command line, and we type C for curve. And we could use pop up a curve calculator if we needed, or specify an out tangent if we had that. But right now, by default, it's asking for a radius. I'll just put in 200. And wants to know which way, right or left. Curving to the right. And it wants to know now the length of that arc. You see the other options you could put in. So that's 175-foot long arc. And again, I'll take COR, excuse me, COR as the description. That's my next corner. Okay, and so now the next thing I want to do is I'm going to switch back to bearing. So I'm going to type B. And it wants to know the quadrant. Whoops. Yeah. There we go. So it needs to know the quadrant and the direction. So that's the fourth quadrant. That's a northwest bearing of 10, 15, 25, a distance of 200 feet. So that's going to be 4 as the quadrant, 10.1525, and a distance of 200. Again, taking COR. And then the final closing leg is a northeast bearing, which is 1, 25, 40, 30, a distance of 49.30. So that's going to be, I'm sorry, I said 1, the quadrant, yeah, the quadrant's 1. So 1, 25.4030, a distance of 49.30 feet. Now the description is there. I'm going to just call it COR dash POE, point of end, just so I can distinguish the 2 points. Now, when I'm done, before I just press escape, you don't want to press escape, because if you do that, it will throw away all these edits. And so in this particular command, escape doesn't end it cleanly. You have to type E to exit. And when you do that, it writes the deed file into there called deed 1. I noticed when I started, I was right close to my 0 origin, but I'm out here in space, so it doesn't matter where I've got that. Okay. So now, even if you were to, even if all that stuff were not in your drawing, and I'm just going to select everything and erase it, although I do have points, I'm going to turn my default off to not use field to finish for now. But if I list my points, I see that I've got these points, and they're down here. See, some are negative because I was down near 0. No, I'm going to save changes, and So now what you could do with that deed file, once done, you could go back in here and say process. So I'm on the survey menu and I'm going to process my deed file. And I'm going to choose that additional tools deed file. I'm going to select my lot 1 and double click it, or I can choose edit. Now this is where I could make any edits to those calls, and you can see they're highlighting down here. I've got my bearing with my quad and my dd.mmss. I could choose over here to change to azimuth mode instead, so it shows up as azimuth, or back to bearing mode, Q ddmmss, or I could say 3 column. So that lets me choose a quadrant, and then degrees, minutes, seconds. So that's a way that you can edit any of those things that you made. You've also see you've got lines and arcs that you can pull down here. And you can, on curves, you can choose whether to make it tangential, set up your different arc lengths, radius, the curve direction, all those different kinds of things. And so if I'm looking at that curve here, what did I switch? I'm going to cancel. I did something. There we go. There's now my curve. There's my arc. There's the arc length, the radius, the direction, the included angle, which was 50.0802. It simply calculated that, even though, you know, I had it designated over here as such. And the bearing of the from the PC to the radius. Okay, so you choose out of all these points, which one is the POB. So that was my POB core, and then my core POE is my ending. All right, so a couple of things you could do there is you could, if you didn't want that drawn back here where you entered it, you could come up here and say pick, and I want you to pick a point. Well, I can go way out into space a little better if I can get this situated. Oops, I'm like way too far now. Let's see. Well, let's come back and just type this in as a 5,000, 5,000. So I'm going to move it up away from that 0. I don't have to do that. I'm just showing you that you can do this with this. You can say, okay, now it's done. And now you could say, highlight it and say draw. Again, put it where you want it, erase any previous ones, which I've already erased them. Label the points, label lines and arcs. And use our different label settings. We'll say, okay, it's now drawn, done. And we'll say exit. And definitions have changed. Sure, we'll say that. And now there's my deed drawn with my descriptions drawn. Now this is nothing more than text at this point. Because if you recall, the points in my file that I generated when I created my deed are still down here at these negative values. So let's move those points up, and you can do that several ways. You could say, draw locate points, draw all, and it's going to draw them way down here. And I need them to be up here. Okay, so we're going to do a transformation on these points. So we're going to go to points, adjust coordinates, and we're going to do either translate by given amount, or we can say the original point was point number 1. Whoops, not in northern, sorry. Point number. The destination point, well, I'm going to pick, and I'm going to go up here and pick not the end of that line, but the end of this line, because that's where I started. So that's point number 1. So it's going to go from that location to 5,000, 5,000. And I'm going to overwrite existing coordinates. I'll take all my points with that description, and I'll say, okay. Translated 7 points, and now you see they're back. And if I list my points, they now have these coordinates up around 5,000, 5,000. Now notice point number 7, which was our closing point, it missed the starting point by 100s and 4,000s, sort of typical. So now what does that mean? Now, one thing I want to point out too, by the way, if you are drawing this as you're entering the deed description, if you are near another point, like I'm going to just draw a line here, and if I get near that point, you see where it snaps is to that center of that point. That's because I have my settings point object snap is on. Now, if I did not have that on as I'm drawing this deed around, if I had something else near here, when I put in this call, or any line, if I put in a bearing and a distance, and if it gets in proximity to something that might be drawn down here, say line work, and I've got my object snaps turned on and I grab the end point. If I'm zoomed out at such a level to where it would find that with a snap, it might snap it to a different location, which would actually change the bearing and distance. So once you put these in, if you're not using that point object snapping, make sure that, double check your resulting work here to make sure it didn't miss something and pick up on something else that was already drawn. Okay, so in this case, we didn't have anything, so we're all good. So now we have a deed. We recreated that from the deed file. And as you can see, if you had more than one deed, you could just draw all those deeds all at once, and it would generate them out here in the drawing. But now, what else do we need to do to this deed? We need to resolve that little discrepancy in there between point 1 and point 7. And you can find out some information about that process if we come down here and choose map check, either by points or by screen entities. And if we do by screen entities, let's choose OK, and we'll choose our boundary as our line work. And if we wanted to choose text, as our bearings and distances, we'll choose, and we just choose a sample of it. We don't need all of them, just the one. And now what to process, and let's just grab it all. And here's where you can set up distance bearings, et cetera, and we choose OK. And it reads their deed. There's that first call. And then there's our arc information. And there's our closing leg. So their ending coordinates were this. Okay, so it should have been 5,000, 5,000 flat, but as it is, and it generates the area for us, the perimeter, and gives us our closing error of 0.01 along that bearing, and calculates the precision for us. Okay, and that may be sufficient. It's asking me to save the deed file. I'm not going to. I'm just going to exit. It's already saved. All right, so that gives you some information about that you could use your typical survey knowledge on how to resolve that boundary conflict. Okay, now you can do a legal description writer, for instance, and you can set up again all of these different settings and how you want to generate that. And I think if I leave the defaults alone, no, I've got to pick a boundary. And then go, here's the beginning of POB, there's my first one, my second one, my third one. There's the curve. And as you can see, and then it comes back to this core POE. So it's reading those descriptions, and then it tells me which is the point of beginning, because that's my last call. All right, and then you could use that as starter text to go off and finish, you know, adding things like, which is also the southeast corner of blah, blah, blah. Okay. So now, next we're going to look at a couple of deed tools, or one here by deed correlation. Now notice one thing you can do, we don't have an example to show you, but you could do a deed file by interior text. So if you had a drawn block of lots, you could just polylines to deed files. If you had those drawings, you could choose those and it would create those into the deed file, which is what we read with those calls around the deed. So, but the deed tools that we want to look at next is going to be deed correlation, and we need to set up a couple of things here about with that. So this is going to be a process whereby if you've entered deeds and generated some points, we're going to then compare those to a set of points that we find out in the field and see how they relate to these particular points. And then we could move this deed that we drew into our field location, or we could move those field points into this deed location, either way that we want to do it. If you're surveying these field points out here and they're out on state plane or something, you could then correlate them back to what you've already started drawing up your mapping. And so you bring those points over. Now you lose the coordinate value when you do that. So you might want to bring the deed into the field points if you're wanting to preserve those. But here's how we're going to show you how that works. I want you to select that polyline that drew. And then I just want you to copy it over here off to the side a little bit. Okay. And then I want you to select it one more time, and let's give it a rotation. And let's rotate it around this upper point here, and just a little bit of a rotation, not a whole lot. Let's say something like that. So you could even, you know, we didn't have to anchor it at a point, so it could be out here in space. Now, because we have in this area, we've got this little overlap on this figure that we drew. I'm going to zoom into that point, which is right there around our POB, until I see those double points. And I'm just going to grab one of those and bring it back, snap it back to that point there. And I'm going to go over here with my polyline selected. I'm going to change it to, yes, it's closed. So now I can just do some grip edits on these points. So again, I'm going to zoom in real tight on one of these points. I'm just going to grab that grip and move it just ever so slightly. Let's see how much. That looks like 0.01. 2 or so. So I moved that one in and down a little bit. That's no longer collinear. Let's go out here to this other corner point and let's tweak it a little bit to the outside here. don't want to move it all that much. It doesn't matter, it'll still work, but get the idea. Now I'm going to go to this point. No, I think I'll leave that one alone. We'll leave that. Just tweak a couple of points. I did the POB, I did that opposite corner. Let's maybe do this one too. Okay, so they're in slightly different positions. So it's not exactly the same field here, but we've got this figure now. Okay, so next we want to generate some points. So I'll go to my Kogo menu and choose create points from entities. And I'll go ahead and set those back to be circle point. And I'm going to put them on a layer called points underscore FLD. And I'm going to start these points instead of the next one up. I'm going to say 101 just to help us out. And it's going to look slightly different here. Okay, so same description for all points. I'm going to say FLD. I'll say okay. Which polylines to process. I'm going to not generate the radius points or the midpoints. So I'm going to skip those and I'll draw those new points. I'll select my line. And there now are my points. I've got 101 that starts down here, 102, 103, 4, 5, and 6. So it went left to right in that order. I was hoping to try to get those in that same order. Let's see. I double click down here on 101 and I change that point number temporarily here to 999. Yes, I'll delete point 101. And now I'll go up here to this one and make that 101. This one needs to be 106. So if I turn this one temporarily to 999. All right. Take 105 out, yeah. So this one needs to be 102. Three. Make this one 104. No need to really do it this way. It'll just make it easier. This will be 105. And then this will be 106. Sure, 102 is where it's supposed to be. Yeah. All right, so now I've got 101, 102, 103, 104, 105, and 106. So I've got a set of field points. I've got a set of deed points or corner points, POB and corners, and they match up 1 through 6 and 7 to 101 through 106. So I found some of these points over here in the field. I want to see how they relate to my deed. So Go to survey, deed tools, deed correlation. And we're going to make a new deed correlation file. We'll call this additional tools as well. Say open. And what we're going to do here, we see a column under survey point, a column under deed point. So once we're done with this, we're going to want to bring our field points into our deed points, or let's go taking our deed points to match our field locations. So deed to survey. So now we need to start adding points. So I take a survey point, which was 101. Deed point was 1. We'll then add survey point 102 to deed point 2. We'll add 103 to deed point 3. Add 4 to deed point 4. Add 105 to deed point 5. Add 106 to deed point 6. And then finally, we're going to add again 101 as our survey point, and we're going to check it against point number 7, which is our deed point, to see if maybe it's a better fit. So 101 to 7, 101 to 1, 102 to 2, 103 to 3, 104 to 4, 105 to 5, 6 to 6, and 101 again, looking at point 7. Okay, so now I'm just going to come down here, hit the save button. So I've got this list of points that I'm going to check. And a couple things to do now with these tools down here. If we first run an inverse report, you're going to see your survey points in this column, your deed points in this column, and it sits on each survey point, point number 101, and it inverses between all of those other points. So 101 to 106, for instance, is that bearing and that distance. The bearings won't match up right now, but we were checking the distance, 49,276, that was 1 to 6. So we come over here and we say from 1 to 6 was 49.289. And up here, we matched it as 49.276. So, you know, a little bit of miss there. And so this gives you a comparison by stepping through each of the survey points in order. And then it goes from each of the survey points, holding on that point, it inverses to each of the other survey points all the way down the list. Same thing for deed points, deed to deed. So you can get a look at how they relate to themselves. Okay, so this used to put those in put them in descending order, and it apparently put it in reverse order for me now with this new version, but in any case, it doesn't matter. So that was our inverse report. Now you can do a compare before a line, and that was our correspondence, 101 to 7, 101 to 1, to 2, to 3, to 4, to 5, to 6. And you can see how much they would have to move in the X direction, how much you have to move in the Y direction if we just picked up our deeds and moved it to our field points. That would be those directions. Okay. And you can check an alignment. Let's suppose we're going to check, let's say, let's hold in our deed points now. Let's hold our point number 1. And we're going to, 1. And we'll rotate into 2, 3. Let's see, let's go across the thing to point number 3. And we'll say, okay, for that. And it says, okay, if you hold deed point one, which was survey point 101, and you check the rotation from deed one to deed three, and you compared that with survey 103, then here's what would have to happen. It would move this distance, X and Y, rotate that amount, but this is the amount of miss. That's basically the miss closure on that as it was before. So then down below, you can see these distances, 0.011, 0.022, 0.03, and it shows you the differences, the deltas X and Y, if you did that transformation based on that particular check. All right, and that just lets you pick a point to hold, pick a rotation to hold. Maybe this line down here was the one, so 5 to 6, if we checked holding point 5, rotate into 6, if we hold that steady, that's going to give us a little better residual. Instead of 0.02, it's 0.012. So that's much better. Maybe that's how we would resolve that. All right. But then you could also run this button here, find minimum alignment. And so it does that process of checking each of those alignments. And it says your best bet is to hold 0.4, rotate based on the rotation to 0.5, and then move all those points into this coordinate space like you would do here. So 0.7 would have to move a little bit from its original position, 0.1 even less, but that still comes up with this residual direction. Now that 4 to 5, remember that was the one that I just did the check on before, which is not why it picked this. It actually finds mathematically the best one for you. And so you need to either check alignment or do a find minimum alignment, whichever one of those that you want to do. If I were to check alignment, let's say 3 to 4 this time, 3 to 4, then you see that's a much larger residual, but that's 3 to 4. So now I've checked that alignment. If I say apply alignment, you'll see it uses 3 to 4. So we're not going to do that one. I don't know where it went. Deed tools, deed correlation, load up my deed correlation. So that was at alignment 3 to 4. And I saw that that wasn't as good, or I can find the minimum alignment, and there it finds it as 4 to 5. So see, it looks at all of those one at a time and finds you the least amount of changing that you're going to have to do to that set of points to correlate them to where you found them in the field. Okay, so that for those of you who are actually doing boundary resolutions, that's not gospel. That is mathematically the least amount of motion. There's other rules that play into this, as you know. You know, you've got your precedents of evidence, you know, which things are, you know, I know that I want to hold this point, and I know that I'm going to hold this bearing because the evidence out there is really good. I found a really well-preserved corner here and here, but these others were bent or missing or what have you. So once you hit that find, whatever alignment, you either check one or you find one, and then you apply that alignment, it's going to take that. So now it's using 0.4 as our first point, 0.5 as our rotation point. Of course, it fills out these. So it knows that 0.4 needs to match up to 0.104. 5 matches up to 0.105. Range of points, you know, in this case 7 through 1, because that was in the list of my order, or I could just say all, or I could limit that to 1 to 6 and leave 7 alone if I wanted, you know, any way you wanted to stipulate this out. Now, You may notice it says right here, align points, translate and rotate. That's the very same tool that's over under your points menu to do that point transformation. Now there's a couple of things here. If I'm going to be moving my screen entities, in fact, I'm going to cancel that for a minute and select that original thing and just get rid of it. Just to go back to now survey, deed tools, decorrelation. I'll find that minimum again. I'll exit and I'll apply this alignment. So now if I check this box right here that says align screen entities, it's going to prompt me to select things that I want to also move over to this new space. So if I've drawn anything that I want to, maybe I've got a building footprint here and a tree and anything else, I can make sure that those come along with it. Now this is anything that's drawn out here. So it's going to be the lines and the bearings, although the bearings would recalculate if I wanted to re-annotate those. So when I do that, of course, it's going to tell me the delta X and Y and the rotation. I'm going to ignore any elevations. But when I do this alignment, now you could use elevations if you had some elevation difference, but they're all zero, so it won't apply. But now watch what happens in this prompt. This is very important. When you say align screen entities, you say, okay, and it says select objects. Now the tendency is going to be to just grab everything. But it says in the line above, select objects to align, points excluded. So you have to make sure you do not choose the points because they're already going to move in the transformation. We're just selecting other things to move. So if you also include the points when you say other things to move, it moves the points and then it knows to move that item that just now got moved over here and it moves it again that same amount. So you would wind up with this drawn figure over here and the points would be temporarily over here and then they would be moved over to here. So that's why it says points excluded. Just make sure you're aware of that. So I'm going to now do a crossing selection of my polyline and those labels, and I can just cross these. I just want to make sure that I don't get any of the points. Now I'm through selecting, I'll hit enter. It says align 7 points. Now these red things here, those were just those text descriptions that happened when I drew the deed file. I can now select those and delete them if I want, or move them if I want. Now what happened down here? This is a piece of annotation, so it got repositioned because it was a block. So what you would do for curve labels, if you wanted to re-annotate those, is you would just grab that block and then go back to your annotate menu, and you want to annotate a curve, which is going to be, I want to put it in the table, annotate an arc. Just label the arc. I'm going to stack the arc length, say L equals, so R equals. I'm going to use delta for the delta angle, chord, tangent, anything else you want there, bearing, type of curve, road, draw, leader. All right, that should be sufficient, I think. And then I'll select that arc and I'll put it down here, for instance. All right, so now there's my curve with my arc length to 175, 200-foot radius. I didn't clear out that D prefix. I just used the delta. So if I back in my options, take this out. Say equals, use the symbol, say okay. There we go. All right, so now, remember we held 0.4, so 1, 2, 3, 4, and it rotated into 5. So that 0.4, if you zoom in here real tight, you'll see that this polyline goes right through where that point location is. And 0.5 is probably close. It is, but the rotation would match. So those two got, and they weren't tweaked, but remember we slightly tweaked these points. I can't really, there we go. If I select that, so that original point, so my field point is here, but my deed point is this white plus mark. And the red line now was the red line that drew from the deed, but to best fit all the data, it didn't distort this line. It just moved the points as close to that as it could based on that transformation. And I think we also tweaked up here. So if I see, you know, there's the actual field point. Looks like that was a real tight fit. I can't even really get in close enough to see if I select that. Now maybe I can see. Yeah, so you can see how much it misses there, just a wee little bit. Okay, so that could or could not be all that helpful. Here you see 0.1 and 0.7, and how they are close. And there is the original polyline. You see where one's up here and the other one's down here. Those are my two deed points. And yet my field point is here. The two deed points are here and here. So that's as close as it got now. So what did it do when it did that correlation? It did not change, even though my field points are slightly out of position relative to themselves. It took all of my deed points and they're still exactly the same way they were in the deed. If I inverse between 101 and 102, I'm going to get those original labels, much like I had when I brought this over. Now, this is now, instead of, what was that first thing, north 25, 30, 45 east? See, it's now north 38, 04, 04. So it did recompute these because they were annotations. And I have in my Carlson configure general settings, I said link labels with line work. Okay, if I did not have that, it would have just copied them over and they would have been meaningless until I recompute those labels. So again, these bearings and distances are still reading this figure, which is still exactly the way the deed was. So you'll see that all of your distances are exactly like they were when we entered the deed, even though our points are slightly different. So close, I can't even get into it far enough to see it. Okay, so you may or may not find that to be of a lot of use, but I find it to be really helpful to check and see how the points you find out in the field, you're not even sure if it's, if it's a particular property corner, but you may want to find, maybe you found 3 or 4 points out in this corner and you would include that in your deed correlation so you can check and see how that might work if you can find something that brings everything into correlation a little more quickly. Okay, but again, you cannot give up the the responsibility of being a good surveyor. You can't throw evidence out the window and all of that. So that may or may not be helpful for you, but it's a good mathematical tool to help you generate that. Okay, any questions on any of that stuff?
Yeah, I have a question. It's similar to an area that I've run into a few times with.
Okay.
It's with deed writing, but when you have a plat that doesn't have any bearings and distances, is there an easy way to do a deflection angle? Sometimes you get a plat that'll just have deflection angles and they won't have any bearings on them. Instead of like figuring it out, bearing wise, is there a quick?
Yeah, to enter the deed and it's got deflections instead of bearings.
Yeah, or just even drawing a line and then having it, go 30 degrees. Yeah, like angle right 30.
All right, so if you're trying to, yeah, even just drawing lines, sure, there's a way to do that. Let me show you how you do that. So whether I'm entering a deed or otherwise, if I'm entering a deed, let me see if it's on that possibility here. If I do traverse by bearing was what I had set up. If I change it to prompt. And now deed name, sorry, I'm still got this lot one. We'll call this one test. I'll just pick a point here now. We'll call that one POB as well. So now you've got this prompt and it says angle bearing code. By default, it's 1. Now the codes are this. There's another tool that actually repeats those for you, but what the codes are if you think of the quadrant 1, 2, 3, 4 as your northeast south, that's if you're doing bearings, but 5 as a code, and you put this code in by itself before the rest of the angle. So if you put 5, that's an azimuth. Then 6 and 7, 8 and 9 are your deflection left, deflection right, and angle left and angle. No, I got that backwards. 6 and 7. It's angle left, angle right, and then deflection left, deflection right. So if I wanted to do in this case, I'll take it at this bearing at 45 degrees. We'll go 200 feet. And we'll call that just a test. And now I put in a code. If I want to do a deflection of, say, 90 degrees off of that, well, let's do a deflection. Well, a deflection of 90 degrees will come this way. So instead of angle right or figuring out what the bearing is or angle left, if I know that deflection, my deflection right code, I think is 8. And let's go that one of 90 degrees and we'll go 100 feet. All right, I think I had them backwards. That was a deflection left. It was code 8. All right, so anyway, that would go ahead and escape this. And let me show you though where those codes are. I just misremembered them. Those codes would be if I'm putting if I'm just going to draw a polyline and then come here to here. No, it's not. I want to see where the prompting is. Do traverse. So that was my previous setup. Let's start down here. What do we have? 1 to 2. So if I inverse 1 to 2, now if I say T to traverse, angle, enter angle right, if I say O for options and I prompt for the angle, say okay, and now it wants to know an angle bearing code. It's not doing that anymore. It used to right up here in the line above it, it would tell you what those codes are. Does yours do that? If you do a just to draw a 2D polyline and go pick a point to another point. And then if you go D for distance, and let's say I went 100 feet, what direction? If I say A for angle, there it is. That's what I was looking for. It wants to know the angle code, and there's your codes. 1, 2, 3, 4 are your quads. 5 is your azimuth. 6 and 7 are angle left and angle right. 8 and 9 are deflection left and deflection right. I must have put the wrong code in. All right, so if I use a deflection right, number 9, and I go 90 degrees, let's go 100 feet. Let's go 150 feet. And then if I go A for angle again, and I go a deflection left, let's go 90 degrees. Oops, sorry, deflection left was 90 degrees, 100 feet. That's deflecting. So I went here. Oh, it's a deflection. Here to here should be a deflection right. Here to here. Deflection right. So if I do a deflection left, 8 of 90, just go 50 feet. Yeah, so all right, so that's working. I just I just misput one in from what I was thinking. And then I can just escape to finish that up. All right, so that was just in the middle of just drawing polylines. If I'm drawing here, instead, if you don't know which way you're going there, but well, let's say you do have a starting orientation. Now, to be able to put in that angle, you're not going to pick a point or a point number, but you're going to put the distance that you're going to go. Let's say 50 feet. And now it wants to know which direction. At this point, you choose A for angle, and then you put in the quadrant. If it's a bearing, if it's an azimuth, you put a 5 in. So you answer this code question first. So you're unlike the bearing entry where you put the quad and then the dd.mmss, you're going to put in the code, special code first. So it's going to be, at this point, if I do a deflection right, that's an 8 for my code. What angle? Let's go 45 degrees. That's not, did I say, I said deflection right. All right, if you're following along, Chris, did it do Is it doing that same thing or do they have that one messed up now too?
No, I think it's doing the same thing.
All right, so here to here. Or a distance of 50 feet. Angle. It's a deflection left. The deflection should be. Deflection right of 45 degrees. Oh, it's working. I'm for whatever reason, I'm thinking of it backwards when I'm sitting here talking to you about doing it. All right, and so now you would enter another distance. Let's say this distance is 100 feet by angle. And let's do a deflection left this time. So I'm going to go up the page of 90 degrees. Yeah, so there's me doing that just with drawing line work. Now, if I do that in my deed description, let's start a new one. We'll call it test 2 because I'm appending. That's why it prompted me for that. And I changed my traversing to prompt mode. Now I'll start here. Call it test 2. I'll give it a code, which was 5 for an azimuth. Let's call that 45 degrees. And I'm going to do that, say, for 50 feet. All right, so it's now drawn that. And now if I deflect, give it the test 2, the angle of bearing code, that was a 5. Now, if I deflect left, it's, or an angle right is 6. No, angle left is 6, angle right is 7. Deflection left is 8. So if I do an 8 and do 45 degrees, say 50 feet. Yeah, that's working. And now if I do a deflection right of 90 degrees, and I should go to the east, say 100 feet. And now I could do an angle right of 7. Whoops, give the description now. The bearing code 7 is angle right, 45 degrees, 50 feet. And I'll exit that. Okay, so the answer is right here. You have to turn that to prompting. If you're always putting in bearings, you can set it this and it won't prompt you. Otherwise, it will prompt you. And you can also set that in your Carlson configure. Not in my general settings, but in my drawing setup. If you look at that, you can set that to this. And if you say other, it should prompt. If you point default, that's only going to prompt you for verticals. All right, so that would be, and unfortunately you just had, and if you do that a lot, you'll remember the codes. 1 through 4 are your quadrants, 5 is your azimuth, then it's deflection left, I'm sorry, angle left, right, and then deflection left, right as 6, 7, 8, and 9 as those angle codes. And again, it's the drawing setup either here to set that all the time, or you could go back to simply your drawing setup. And does it have it in here? Nope. Yes, right up here, angle mode, bearing, azimuth, gone, or other. So set it to other and it'll prompt you. Okay. Now to show you how that's also going along, if I process this deed file again, remember that lot 1, I now have lot 2, and that's the one that I just drew and I erased. And you could change where it starts and replot it, etc. Okay, did that clear that up?
Yeah, thank you.
You bet. All right, so let's take a look at, let me see what else to talk about. We talked about some annotations, some data sharing. Let's take a look at, oops, I'll go here. The Kogo earlier. Let's do some quick LotNet processing. And when you look in the book, it will show you some, it will, tell you some concepts to use here. But what we're going to do is we're going to open this other file called Clearwater Oaks, and we'll make a new coordinate file. And it's going to have a closed boundary and these center lines of streets. And so that is a requirement when we're doing LotNet processing, is we have to have a closed outside boundary. And then we have to have these inside lines for our street center lines. So we're going to open up Clearwater Oaks. Well, I'll leave that one up for a minute. Let's open Clearwater Oaks. And it's going to look like this. All right, so we have our boundary, we have center lines of streets. So what LotNet is going to do is, and it's on our area layout, and here's where our tools are. We can set up some settings. Don't have any existing data files in there to load. But anyway, these are all coming out of this section right in here with boundary tools, area tools, all the different things to help you create this as a subdivision. Now, and you can do them from this menu. I find it easier if I'm going to do some LotNet processing. If you bring up your LotNet toolbar, I have to see where did it stick it, right in here. LotNet, yeah. It's a little easier to follow from the toolbar because the tools are done typically left to right as you work. So this particular one here is our settings. And we don't have a network file to process, so we'll just say new, we'll call it Clearwater Oaks. And now we say, all right, do we have a road network? And this is if you have from the civil side of the software, you could have a road net that will compute intersections and things like that, but we're not going to have one set. We'll start with lot number 1, give it some tolerances. Let's just take these defaults for now. You can output a lot file if you wish separately from, and that lot file works like the deed file. It generates all those individual lots within that lot file, but you don't need it because you've got this network file. Now, automatic label updates, if I turn that on, so when it labels it, and if I make changes, it will automatically change it for me. My lot line layer, my building placement, if I have any buildings to place, I can make edits to those, tell them that I want my buildings to go a particular front setback, side setback, in the rear, draw the setback lines, building pads, all kinds of things I can do to control that part as well. We'll just take the defaults for now. I'll label my lines and arcs, and I'll label my areas. And I'm going to take the defaults for now. I could add some additional lot types down here. I don't have any of those to add. I'll say, okay, so I've now done my settings. So now working left to right, if I try to go over here and do some of these other tools, it won't let me because I have not established the boundary yet. So I choose boundary, and I set that outside boundary. I'm finished, so I'll hit enter for that. Now this one will create that road network that we didn't have from these road center lines. So I'm going to pick that up and we'll make a new one. And I'll just call it Clearwater. And here's where you put in certain rules about the roads. I can have roads, intersections, and cul-de-sacs. And I choose that by adding my roads. So if I add, I've got these drawn, so I'm going to screen pick the polyline. I'll choose this one and assign that as a centerline file. And I'm going to call that one Main Street. Okay, so it's now in there. You could establish right-of-way offsets. Right now, we don't have any. If we added, it's go, oops, we don't have a file set. Make a new file here called Clearwater. Then we'll edit that and we'll say on a right-of-way layer, where left and right, we'll go 25 feet. Any additionals, we'll say that exit. And we'll say, okay, this template point center line, this all ties back into all of this mess, which is more in the civil design. You're typically not going to have that, but that would be like if this center line comes in and it's 50 feet for the right of way, but then center line may be peeled off and had an additional, like a road widening kind of thing. You could add all of that stuff in there. So, but this is good enough to set that up. So now it knows where Main Street is, it knows how wide it is. And let's add another road. I want to add a road or a cul-de-sac, I'll add a road. By screen picking the polyline, I'll pick this one now, assign a file, and I'm going to call that one Elm Street. Same right-of-way offsets, I'll say okay. I'll add a third one. Center line, whoops. Add a third one, road, screen pick, and this is going to be we'll call it Bridge Street. All right, so now I have these three in here. If you double click it, it lets you change those same things that you saw when you added it. But notice what shows up here. See, I can't add an intersection, but it finds the intersections. And if you look at that intersection, down here, front left, front right, it lets you set in the right-of-way radius, or you can make it a chamfer. And front versus back, if you look at the settings, it tells you here's Main Street. My primary road is Main Street. So Elm Street is the crossing road. So here's Main Street. Here's Elm Street. And since Main Street goes in this direction, when I get to these right-of-way radius values, front right is over here, back right is over here, because it's in the direction I'm traveling. I get to the one over here. Now, if this roadway crossed over, if it was a four-way, I would see a front right, front left, back right, back left. Okay, so those will show up and you can put in default values for those radius values. All right, so we'll leave those as 25. We've got the same thing here at Bridge Street, the very same processing. Now, if I want to add a cul-de-sac, I can right click, choose add, or choose the plus button. I want to select Main Street as the one I want to add. At the end, and we'll just use a standard style. Give it a cul-de-sac radius of, say, 65 feet. Let's see, we're talking about the right of way here. Let's better make that. So let's say 85 feet. That might be okay. It might be too big. And then our right of way radius as it goes around here, like such. 25 feet. We'll say okay. So there now is, if I select it, shows you where it is. It highlights it there, and it should see it. There it is. So again, that lets you redefine that and say, okay, and that's all we need. Let's look at the settings here. That sets our intersection radius defaults. Process on updated files. I'm going to just turn that to be automatic. Output lots. Lot settings. Let's see, what kind of a square footage might we have? Let's say make them 20,000, make them about half acre lots. Minimum frontage, minimum lot, maximum lot, minimum back distance. They can taper to a point, or you can make a minimum distance. An interior back, reduce offset, and then the lot lines from the right of way, it's either going to go perpendicular to the right of way or perpendicular to the back line, or you can set a specific angle. Now, what's left over after it generates lots? What do you want to do with that leftover? You can spread that among all the lots, or you can make a separate end lot regardless of what size it is, or you can add it to the last lot or create a back lot edge. And if you create a back lot edge, it's going to come in here and put a back lot line on all those lots such that you've met this size up here. Otherwise, it adjusts these to go all the way back to the boundary. And then you need to decide what to do with any leftover properties, any leftover area. And let's just, at this point, we'll add to the last lot. We'll make that the builder's lot. And we'll say, okay, say, okay. So that's now been done with our road network. We'll save that and we'll exit that. So now we've done the boundary, we've done our road network. And now here's, you can add additional items, add additional right of ways, lot edges, remove a lot edge once it's done. Do all of these different parcel adjustments that we'll try here in just a minute. Redraw, get a report, load the inspector, and renumber the lots. All right, so now that we've done that, I'll click on my road network again, and I'm going to choose process. So it's going to go through there and automatically do all of those things that I had set: automatic labeling, automatic lot line placements, and all those targeted areas. All right, so if I exit that now and zoom in here, let me see what these this is, make that a little nicer. Actually, I'm going to do Arial narrow. Okay, so there you see what it's done is it's gone around label. Now there's that outside. There's a little bit of a thing there. If I have my default setup to use line tables and curve tables, it would do that accordingly. Right now, my defaults are not set, so I've got these really tight looking things in here. Okay, so you could obviously we'll change our layer information. Now I've got this outside 227.57. That's this line here, whereas the 119 or 178.19 is this one here. So you'd perhaps have to make some adjustments on those bits. But see, we've hit our target area. Here was our one that didn't make it by that default. Couldn't quite get 2 out of there. It left it as 1. Here was our last lot, 37. Run our inspector. Lot 25, 24 is my lot 33. So let's see, lot number 12, 11, 10, 9, 8, 7, 6. That was lot 2, lot 1, lot 2. So it did those in that order. If I renumber lot 1, pick a point in the start. So I'm going to say start here with lot 1 and go in this direction. Let's turn my and then finally here to here, here to end. So that now should have. So there's my lot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way around the way we remembered this. Now we didn't see the lot numbers show up. Apparently I didn't. Let's see if I label. Let's use line tables. If it's going to be over 1 inch long, let's say 1.5 inches. So I'm just changing my auto annotate defaults is what I'm doing here. I go to arcs, use a curve table, my scalar again, say 1 inch, They're stacked now. That should be okay. Our areas, let's edit that. Square feet and acres. So the lot. So that description. Let's redraw the labels. Starting point for the curve table, I started over here. Starting point of the line table. Started over here. So now I've generated this curve 19, lot 50, or line 57, curve 18, line 58, and they correspond to these tables. Of course, because we have auto update turned on, you would see any changes I make will update these. So there's my lot numbering. I could, put circles at my little corners if I needed. Now, once you've done that as a good starting point, you could then make changes to this, add a lot edge, remove a lot edge. If I removed this lot edge, right now I'm going to add back a lot edge. I'm going to go from, oops, I guess I need to draw it simply. I'll go from here to here to here to here. Now if I add this lot edge, fix this one. So match that. So I could take this one, move to here. Simply extend that. And now I need to those two as lot edges. Right, now I've got this large lot over here, lot 21. Because of these edits, I've got this one here, lot 31, 37,000 square feet. If I subdivide this, I'm going to pick inside here and use an automatic method. I'll set a target of 20,000. Any remainder just add to the last lot. Pick the end of the frontage. Get no more than one. Let's do that again. Instead of 20,000, let's make those 15,000 square foot lots. So there now, it subdivided that, and there's my 15,000, but I had extra that I added to the last one. So we have these adjustment sides where we can move a lot edge point, or we can do this sliding side or hinged area. So if we simply do a sliding side area for this one, we adjust this lot, or we adjust this side. We want to make that a 20,000 square foot. So it now is 20,000. This one now is the lower one. Okay, so all of those are individually things that you can do as part of this network. They're just the same things as you see up here, this adjust areas, hinged areas, sliding side area, all of those different type tools. It's all contained in a single spot. Okay, so a nice bit back to our road network, which controlled these settings. Said our setbacks. Look at my lot network settings. I want to draw the lines and arcs. I'm not seeing where they moved that. We got a front setback. So if I draw the setbacks, but don't place the buildings. And now if I update that, I don't think. There we go. So that's now complete with my setback lines drawn in. And you can make those adjustments, like if you wanted to bring that to the actual corner, you could do that as well. That would of course change that, those two areas. But you know, so if I simply take that to that corner and then re-update, there you can see it's adjusted the areas accordingly. I could then, you know, make this sliding side or hinge side, either way. Let's do a hinged side. If I pick inside of here, I'm going to select this lot line and let's make that a full 20,000. So it swung it over by holding it here, which of course reduced that size, but it got me up to that 20,000 here. Okay, so see some of the tools that you can have. We can subdivide this lot now. Now, I could add a lot line in like this, but it always tries to make sure that you've got access to a right of way. So this one would, well, I guess it's got it back here, so that would work. So if I subdivide, sorry, right here, subdivide this area. Or even quicker, if I know I want to go from there to this right line, let's just add a lot edge. Oh, we gotta draw it first. Sorry about that. If I draw. Doing the right layer this time. Go from here. We'll go perpendicular to here. Now we'll add that as a lot edge. And there you go. What's going on with this one? It's not. Connected. Add that as a lot edge. Okay. They can be 19.4, 29.1, so I would maybe do a sliding side. This lot, choose this, go to 20,000. Area. Sliding side, this lot, this edge, 20,000. It's not. Something that's not able to resolve, probably can't keep the other rules in place. If I slide this, choose that side. So it does that one okay. Same thing with this one. Choose this. Well, for some reason that's not adjusting. I'll take a little bit of manual work. Or I could move that lot line. Select the polygon is not a lot. Oh, maybe I have to add it back. Oops, sorry, add. Something is missing. says it's assigned. There's a right-of-way line also. Lot 24, lot 28, that's correct. Well, for whatever reason. All right, now it's back to being a lot edge. So that should allow me then to make this, choose that and make it 20,000. If it's not, yeah, it's not finding it. It somehow or another, it's assigning that as being a right of way as well as a lot edge. But in any case, you see the idea behind it. And of course, you would set your layers up to be proper colors and all of that. And you've got in here a situation where you've got all these little individual line segments. And I would say perhaps, yeah, I would remove these vertices and maybe convert that to an arc. And then if I updated, will it recognize that? Yeah, it looks like it. Yep, turned it into a curve. Okay, so just a couple of little tweaks. You know, I pretty well have my subdivision laid out and done. I would, if I tried to subdivide this large lot, it's going to make two skinny lots. I can't do it. Yeah, I could. I got it right away on either side. So if I just draw from here, and let's go perpendicular to the boundary. And let's add that as a lot edge. There we go. Now I could, let's move this lot edge. Let's subdivide that area. So if I have enough, the frontage start here. Yeah, it's splitting the side. That edge. Oops. So do here 20,000. Let's just apply equally to all lots. Say okay, and now when I started there, it went that way. Let's start here. Still. Still gonna do it. All right, so I moved the lot line. And so if I want to split that, still think it would be easier. Subdivide it, just a matter of where I pick the frontage start. No, it doesn't matter. Which one that is. Try it one time. Pick it here. Yeah, it's still always trying to do that between these two right of ways. So my initial placement would be like such. Go perpendicular out here. Update. So now I've got just under 20, just over 20. I could either choose the difference or what's my, maybe just add them up, divide by 2, see what it is if I wanted them equal lots. So if I do this one, adjust that lot and make it 20,000. Missed that. Pick here, pick that lot edge. And if I draw and that. It doesn't like what I've done with that. Okay. Still doesn't seem to like that. No, still there's something that doesn't much care about that particular lot line. But in any case, that should give you some idea about how that can give you some extra time. If you wanted to then adjust those lots. I should be able to slide that, the sliding lot line. For whatever reason, and it's perhaps because this is not closed. It shouldn't have mattered. Let's see real quick. Just that. Nope, it's still unable to locate edge on lot. Even though my inspector says, see, it dashes the outline. Lot 10, lot 21. Those. So it's doing all of that processing by enclosed areas, and there's something about that particular edge it's not liking. But anyway, that should give you an idea of how you set this up, set this go about. I would maybe take that particular edge out, maybe move that point and adjust things as you go. Okay, so any questions on that bit? And we are past our time here. No questions, everybody good? All right. So I will stop our share. Stop our recording.